In the silent, unending theater of the cosmos, our star, the Sun, performs a constant, silent symphony of light and energy, defining the boundaries of our home. From this central stellar heart, a vast bubble of influence expands outwards, a celestial sphere of protection that cradles every world we have ever known. This is the solar system, a familiar map of planets, moons, and asteroids, all held in a gravitational embrace, journeying together through the Milky Way. We have sent our probes, our robotic emissaries, to chart these local shores, from the scorched plains of Mercury to the frozen rings of Saturn. But what happens when you keep going? What lies beyond the final distant orbit of Neptune at the true edge of the Sun's dominion? For decades, we believed it was a gradual fading into the cold, empty abyss of interstellar space, a gentle transition from our shores to the cosmic ocean. But the universe is rarely so simple. At the very frontier of our solar system, humanity's farthest travelers found something that defied all expectation. Data sent back across billions of miles painted a picture not of a gentle fade, but of a distinct, invisible, and monumentally powerful boundary. NASA's instruments detected a region so extreme, so counterintuitive, that it earned a truly stunning name, a 30,000-degree wall of fire. This discovery challenges our understanding of our place in the galaxy, revealing that our solar system is encased in a blistering, superheated shell. To understand this cosmic wall, we must first journey there, leaving behind the comforting blue marble of Earth and the familiar lights of our planetary neighborhood. We travel past the gas giants, past Jupiter and its swirling storms, past the majestic rings of Saturn, venturing into the profound and silent dark. Here, the Sun shrinks to just another bright star in a sea of countless others, its warmth becoming a distant memory, its gravity a tenuous thread. Our voyage takes us to the heliosphere, the colossal magnetic bubble, blown by the solar wind, the very essence of the Sun's extended atmosphere. This bubble is our shield. It pushes back against the raw, unfiltered environment of the interstellar medium, a cosmic sea of gas and dust from other stars. The edge of our system is not a place, but a process. It is the location of a great, unseen collision between what is ours and what is other. Two forces meeting in the void, the ceaseless outflow from our Sun and the galactic wind blowing between the stars for millions of light years. For millennia, humanity could only imagine this frontier. But then, we sent our silent, tireless explorers to cross it for us and report back. The Voyager probes, launched in the 1970s, became humanity's first true interstellar messengers, carrying our golden records into the great unknown. Their long and lonely journey has been one of the most profound in human history, pushing the very definition of exploration to its ultimate limit. As Voyager 1 and 2 approached this boundary, they began to detect strange phenomena, readings that did not align with our models of a placid frontier. The density of particles began to change, the magnetic field twisted into new and complex shapes, the solar wind was slowing, piling up against an unseen pressure. They were approaching the termination shock, the first major hurdle, where the Sun's supersonic wind abruptly slows down before meeting the galaxy. Beyond that lay a chaotic region known as the heliosheath, a turbulent sea of plasma where interstellar forces begin to dominate. And it was here, in this liminal space between star systems, that the probes registered the impossible, a plasma temperature of 30,000 degrees Celsius. A temperature hotter than the surface of many stars, found not in a stellar core, but in the supposed cold and empty darkness between them. How could such a blistering wall of fire exist at the edge of our solar system? How could our probes survive passage through it? The answer lies in the fundamental difference between temperature and heat, a distinction that becomes profoundly important in the near vacuum of space. Temperature measures the speed of particles. At this boundary, the interstellar plasma is energized, its few particles moving at incredible velocities. Heat, however, is about the transfer of that energy. And with so few particles spread across such a vast area, there is almost nothing to transfer. So while the individual particles are immensely hot, the environment itself is incredibly sparse. The humathifier setamen is there, but it has no substance to burn. It is a profound cosmic paradox. A region of intense temperature that would feel to us like the absolute coldest deep freeze imaginable. This boundary is not a wall you could see or touch, but a pressure front made of hydrogen, a hydrogen wall, where interstellar atoms slow and stack up. The light from nearby stars, particularly ultraviolet radiation, energizes these atoms, stripping away their electrons and creating this superheated, yet diffuse, plasma. So the wall of fire is actually a vast glowing boundary of superheated hydrogen plasma shaped by the cosmic winds and stellar light. This structure isn't unique to our sun. We now believe that most stars create similar boundaries, known as astrospheres, as they travel through the galaxy. We are, in essence, living inside a protective bubble that is constantly sculpting and being sculpted by the galactic environment around us. The discovery of this wall has reshaped our vision of the solar system, from an isolated collection of planets to an interconnected, dynamic vessel. It represents the first point of contact, the true atmospheric shell that mediates every interaction between our home and the rest of the cosmos. The Voyager probes have since crossed this boundary, passing through the heliopause and officially entering interstellar space, a monumental achievement for humanity. Their journey continues, now sailing on the galactic currents, forever changed by their passage through that distant, invisible wall of superheated plasma. They carry the memory of our world, a testament to the curiosity that drove us to look beyond our horizons and question what lies at the edge. This frontier is not static. As our sun orbits the galactic center, the shape and intensity of this wall changes, responding to different interstellar clouds. We are passing through different cosmic neighborhoods over millions of years, and the heliosphere is the prow of our ship, deflecting the harshest elements. Understanding this boundary is critical. It shields us from high-energy cosmic rays that would otherwise bombard the inner planets, including Earth. The wall of fire is therefore not a threat, but a guardian, a crucial component of the complex system that allows life to persist on our world. It is a reminder that even the most seemingly empty stretches of space are filled with dynamic processes, with invisible structures of immense scale and power. The data from Voyager continues to trickle back, a faint whisper across the void, continuously refining our map of this incredible cosmic structure. The story of the heliosphere is the story of our home's place in the universe, a tale of boundaries, shields, and our unending journey through the stars. Now, let us journey deeper into the physics of this phenomenon, to truly comprehend the intricate dance of particles and forces at the edge of worlds. To truly comprehend the architecture of this distant frontier, we must first analyze the fundamental force that creates it, the solar wind. This is not a gentle breeze, but a relentless, million-mile-per-hour torrent of charged particles, continuously ejected from the sun's superheated outer atmosphere, the corona. This river of plasma, composed primarily of electrons and protons, carries with it the sun's own magnetic field, stretching it outwards like a vast magnetic web. It flows past every planet, every moon, every asteroid, defining the environmental conditions of the entire solar system. It is this constant supersonic outflow that inflates the colossal bubble of the heliosphere, pushing back against the galaxy and carving out our stellar dominion in the interstellar void. Its journey is one of incredible distance and diminishing, yet persistent, force. The solar wind's journey begins in the sun's corona, an environment of such extreme temperature that atoms are torn apart into their constituent components. This creates a plasma, a fourth state of matter, where negatively charged electrons and positively charged atomic nuclei are no longer bound together. This ionized gas is then flung outwards with such immense energy that it escapes the sun's powerful gravity. As it travels, it drags the sun's magnetic field lines along for the ride, forming the interplanetary magnetic field. This structure is not uniform. It has fast streams and slow streams, creating complex turbulence and weather patterns in space that can affect everything from planetary atmospheres to our own communication satellites. This is the breath of our star, a physical extension of its being that stretches billions upon billions of miles into the cold dark. Waiting in the profound silence beyond the sun's influence is the interstellar medium. This is the very substance of the galaxy itself, the tenuous material that fills the space between the stars. It is a diffuse mixture of gas, primarily neutral hydrogen and helium atoms, plasma, and microscopic dust grains forged in the hearts of long-dead stars and ejected through supernova explosions. But it is not empty. It is threaded with its own magnetic fields, and it is relentlessly bombarded by high-energy cosmic rays, atomic nuclei accelerated to near light speed by distant cataclysms. The local interstellar cloud, through which our solar system currently travels, has its own distinct temperature, density, and direction of flow, a galactic current against which our heliosphere must constantly contend. It is the ocean upon which our solar system sails. At the edge of the solar system, these two great forces meet in a silent, protracted collision that has been occurring for billions of years. On one side you have the solar wind, a hot, fast, and relatively dense stream of particles flowing outwards from a single-point source, our Sun. On the other, you have the interstellar medium, a colder, slower, and far more diffuse medium flowing gently throughout the galactic arm. The boundary between them is where a fundamental balance of pressure is achieved. The outward push of the solar wind eventually weakens with distance until it can no longer dominate the inward pressure of the interstellar medium. This interface is not a simple, clean line, but a series of complex, layered structures, each with its own unique physics and dramatic phenomena. This is the front line of our solar system. The first of these structures encountered by the outflowing solar wind is the termination shock. Imagine the wind as a supersonic jet. For billions of miles, it travels faster than the local speed of sound in the plasma. However, as it begins to feel the pressure of the interstellar medium ahead, it can no longer maintain this speed. At the termination shock, the solar wind abruptly and violently slows down from supersonic, around 400 km per second, to subsonic speeds. This is not a gradual deceleration, it is a shockwave. Much like the sonic boom of an aircraft, this is a physical discontinuity, where the density, temperature, and magnetic field strength of the plasma all increase dramatically. This is the system's first warning that it is approaching the Great Wall of the galaxy. Having crossed the termination shock, the solar wind plasma enters a new and chaotic domain, the heliosheath. This is a vast, turbulent region of hot, compressed plasma that acts as a buffer zone between the inner solar system and the true interstellar frontier. Here, the slowed-down solar wind is no longer flowing in a simple radial direction. Instead, it is deflected and forced to flow alongside the boundary of the heliopause, much like how water in a river flows around a large boulder. The solar magnetic field, once stretched out in a relatively orderly fashion, becomes compressed, twisted, and chaotic in this region. It is a tumultuous sea of charged particles, a place where the sun's influence begins to wane and the laws of the galaxy start to take precedence. The Voyager probe spent years traversing this complex and unpredictable region. At the very outer edge of the heliosheath lies the ultimate boundary, the heliopause. This is the surface where the outward pressure of the compressed solar wind perfectly balances the inward pressure of the interstellar medium. To put it simply, this is where the sun's breath finally stops. Inside this boundary, you are fundamentally within the magnetic domain of our sun, enveloped by particles that originated from its corona. The moment a craft like Voyager crosses the heliopause, it is, for all intents and purposes, in interstellar space. It is bathed in particles from other star systems and subject to the magnetic fields of the galaxy at large. The heliopause is therefore the true edge of the heliosphere, a final, invisible barrier separating our solar system from the cosmic ocean. Our solar system is not stationary. It hurtles through the galaxy at a staggering 230 kilometers per second. As this entire heliospheric bubble moves through the interstellar medium, it creates a structure analogous to the bow wave of a ship sailing through water. This is known as the bow shock, a region ahead of our heliosphere where the interstellar medium itself is thought to be compressed, heated, and deflected. This is the galaxy reacting to our passage. The heliosphere is shaped by this motion, compressed on its leading edge and stretched out into a long tail, much like a comet in its wake. We are living inside a cosmic teardrop, forever moving through the galactic dust and gas, with a shockwave heralding our arrival. The scale of this structure is almost beyond comprehension. This brings us to the core of the phenomenon, the hydrogen wall. As the heliosphere plows through the interstellar medium, most of the charged particles from the galaxy are deflected around the heliopause by magnetic forces. However, neutral particles, like hydrogen atoms, are not affected by the magnetic fields in the same way. These neutral hydrogen atoms can continue to drift inwards toward our solar system. As they approach the heliopause, they encounter the hot, dense plasma of the heliosheath. This interaction slows them down, causing them to pile up and form a distinct region of higher density just outside the heliopause. This dense curtain of interstellar hydrogen, heated and energized by its interaction with our system's boundary, is the physical structure we call the hydrogen wall. It is within this hydrogen wall and the adjacent heliosheath that we find the source of the 30,000-degree temperature. This extreme reading is a direct consequence of the immense compression and energy exchange occurring at this multi-layered boundary. The kinetic energy of the particles, both the slowed solar wind and the piled-up interstellar hydrogen, is converted into thermal energy. This means the individual atoms and protons within this region are vibrating and moving at exceptionally high speeds, which is the technical definition of high temperature. However, the critical point is the density. The number of these super-energized particles per cubic meter is infinitesimally small. It is a temperature that exists in the motion of particles, but not in a way that can transfer a meaningful amount of heat. Let us clarify this crucial distinction between heat and temperature, for it is the key to this entire cosmic puzzle. Temperature is a measure of the average kinetic energy of particles in a system, how fast they are moving. Heat, conversely, is the total amount of energy transferred from one object to another due to a temperature difference. A spark from a fire can have a temperature of over 1,000 degrees, but it does not burn you because it contains very little total heat energy. The boundary of the solar system is the ultimate expression of this principle. The particles there possess immense kinetic energy, hence a high temperature. But they are so few and far between that a spacecraft like Voyager can pass through completely unharmed, as there are not enough particles colliding with its surface to transfer any significant heat. The Voyager 1 and 2 spacecraft provided the indisputable in situ evidence for this entire theoretical structure. For decades, the heliosphere model was based on remote observations and sophisticated computer simulations. But as the probes journeyed outwards, their instruments acted as our hands, reaching out to feel the environment. They recorded the precise moment the solar wind velocity plummeted at the termination shock. They measured the chaotic magnetic fields and particle densities within the heliosheath. And most profoundly, in 2012, Voyager 1's instruments detected a sharp drop in solar particles and a simultaneous dramatic spike in galactic cosmic rays, confirming it had finally crossed the heliopause and entered the interstellar sea. It was a watershed moment in human exploration, confirming a multi-layered, dynamic, and incredibly hot boundary. The shape of the heliosphere itself is a topic of intense scientific debate, a cosmic mystery that is still unfolding. For a long time, the prevailing model suggested a comet-like shape, with a rounded nose and a long, trailing tail stretching for immense distances behind us. However, more recent data from multiple missions, including Voyager and the IBEX satellite, suggests a different geometry. Some models propose a more spherical, bubble-like shape, where the tail is not as long and drawn out as once thought. Other theories suggest it may be shaped like a cosmic croissant, split into two distinct lobes by magnetic fields. Unraveling the true three-dimensional structure of our home in the galaxy is a primary goal of modern heliophysics, as it tells us precisely how we are interacting with our cosmic environment. This entire structure is not merely a passive shield. It is an active filtration system for galactic cosmic rays. These are high-energy particles, mostly protons and atomic nuclei, that have been accelerated to nearly the speed of light by supernovae and other violent galactic events. Without the heliosphere, the inner solar system, including Earth, would be subjected to a much higher flux of this dangerous radiation, which can damage DNA and pose a significant threat to life. The tangled magnetic fields within the heliosheath act as a formidable barrier, deflecting and scattering the majority of these lower-energy cosmic rays before they can reach us. The wall of fire is therefore an integral part of the protective cocoon that has allowed life on Earth to evolve and flourish in relative safety. The data collected by the Interstellar Boundary Explorer, or IBEX mission, has provided a revolutionary new way to visualize this frontier. Unlike Voyager, which takes direct measurements as it passes through, IBEX remains in Earth orbit and detects energetic neutral atoms, or ENAs. These are created when fast-moving solar wind particles collide with slow-moving neutral interstellar atoms in the heliosheath. The solar particle steals an electron from the interstellar atom, becoming neutral itself. No longer bound by magnetic fields, this new energetic neutral atom travels in a straight line back towards the inner solar system, where it can be detected by IBEX. By mapping the origin points of these ENAs, scientists can build a global map of the heliosphere's boundary from the inside looking out. The maps generated by IBEX revealed a completely unexpected feature: a giant, ribbon-like arc of intense ENA emissions stretched across the sky. This IBEX ribbon was not predicted by any existing model of the heliosphere. It appears to be a region where the conditions for generating these energetic neutral atoms are particularly favorable, but the exact mechanism remains a mystery. The leading theory suggests that the ribbon marks a region where the local interstellar magnetic field drapes over and interacts with our heliosphere. It is a direct visualization of our system's interaction with the galaxy's magnetic architecture. It shows us that the boundary is not smooth and uniform, but textured and complex, shaped by external forces we are only just beginning to understand. The existence of the heliosphere has profound implications for the search for life elsewhere in the galaxy. Just as our sun creates a protective bubble, it is highly probable that most other stars do as well. These astrospheres, as they are called, would vary in size and strength depending on the star's mass and the density of its local interstellar environment. A star's astrosphere would function as a crucial shield, regulating the amount of galactic cosmic radiation reaching its orbiting planets. Therefore, when assessing the potential habitability of an exoplanet, scientists must now consider not only its distance from its star or the composition of its atmosphere, but also the protective properties of its star's own version of the wall of fire, its own invisible shield against the harshness of the galaxy. The heliosphere is not a permanent, unchanging structure. It breathes. Over the course of the Sun's 11-year solar cycle, the intensity and speed of the solar wind waxes and wanes. During solar maximum, the wind is stronger and pushes the heliopause further out into interstellar space. During solar minimum, the interstellar medium is able to press inward, shrinking the bubble. This means the precise location of the termination shock and the heliopause can shift by billions of miles over the course of a decade. Furthermore, as we orbit the galactic center, we will pass through interstellar clouds of different densities, which will cause our heliosphere to dramatically expand or contract over timescales of thousands of years. Our cosmic shield is a living, breathing entity, perpetually adapting to its environment. While the Voyager probes have given us our first direct taste of interstellar space, their journey is far from over, though their operational life is limited. Their radioisotope power sources are decaying, and bit by bit, their instruments are being shut down to conserve energy. Sometime around the year 2025, they are expected to fall completely silent, their long mission of discovery finally concluded. They will continue to drift silently through the Milky Way, carrying their golden records as inert ambassadors of a species that once looked up and wondered. They are pioneers whose data will be studied for decades, but to continue their work, a new generation of explorers will be required. A dedicated interstellar probe designed specifically to explore this boundary and the galactic medium beyond. The concept for a modern interstellar probe is one of humanity's most ambitious space exploration goals. Such a mission would be designed to travel much faster than the Voyagers, aiming to reach the heliopause in a fraction of the time, perhaps as little as 15 years. It would carry a suite of advanced instruments far more capable than the 1970s-era technology on Voyager. Its primary goal would be to systematically study the entire boundary region, the termination shock, heliosheath, and heliopause, and then to venture hundreds of astronomical units into pristine interstellar space. It would seek to answer the fundamental questions the Voyagers raised. What is the true shape of the heliosphere? What is the nature of the IBEX ribbon? How does the galaxy truly influence our home? Let us return to the nature of the plasma within the heliosheath, the region between the termination shock and the heliopause. The plasma here exists in a state that is fundamentally alien to our terrestrial experience. It is what physicists call a collisionless plasma. On Earth, particles in a gas or plasma are constantly colliding with one another, transferring energy and influencing each other's paths. But in the heliosheath, the density is so incredibly low that an individual particle can travel for vast distances, sometimes millions of miles, before ever interacting with another. In this environment, the collective behavior of the plasma is governed not by collisions, but by the long-range electromagnetic forces dictated by the tangled magnetic fields. Understanding this exotic state of matter is key to modeling the behavior of our cosmic boundary. The magnetic fields within the heliosheath are a subject of particular fascination. The interplanetary magnetic field, carried outward by the solar wind, is stretched into a spiral shape by the sun's rotation, known as the Parker spiral. When this orderly spiral crosses the termination shock, it becomes compressed and amplified. The turbulent, subsonic flow of plasma in the heliosheath then twists and tangles these field lines into a complex, frothy magnetic barrier. This magnetic froth is thought to play a crucial role in shielding us from cosmic rays, as charged particles are forced to follow these convoluted magnetic pathways, significantly slowing their journey into the inner solar system. It is an invisible shield forged from the chaotic interaction of plasma and magnetism, a testament to the elegant complexity of cosmic physics. An interesting phenomenon occurs where the sun's magnetic field meets the interstellar magnetic field. The sun's field has a north and south polarity, which flips every 11 years during the solar cycle. This creates a vast, rippling sheet of electrical current called the heliospheric current sheet, which separates the regions of inward and outward pointing magnetic fields. When this entire structure is pressed up against the interstellar magnetic field at the heliopause, a process called magnetic reconnection can occur. Here, magnetic field lines can spontaneously break and reconfigure, releasing enormous amounts of energy. These events can create magnetic bubbles and turbulence that further complicate the structure of the boundary, making it an even more dynamic and formidable barrier than previously imagined. The discovery of the Wall of Fire is a profound lesson in cosmic perspective. From our vantage point on Earth, space appears to be a cold, dark, and fundamentally empty vacuum. We are conditioned to think of our solar system as a collection of isolated objects orbiting in a void. But the reality is far more intricate. We are enclosed within a vast, complex, and energetic structure that is constantly engaged in a dynamic struggle with the galaxy around it. Our home is not an island, but a vessel. The boundary of this vessel is not cold and empty, but a place of immense temperature and physical complexity. It forces us to reconsider our definitions of hot and cold, and to appreciate that the universe is governed by physical laws that often operate on scales and in regimes far beyond our everyday intuition. So what does interstellar space actually look like once you pass through this wall? The Voyager probes have given us our first answer. It is not a complete void, but it is profoundly empty by solar system standards. The density of plasma drops significantly. The primary population of particles is no longer the solar wind, but the low-energy plasma of the local interstellar cloud and the high-energy, relentless rain of galactic cosmic rays. The magnetic field is no longer the sun's, but the ambient field of the Milky Way galaxy itself. It is a transition from a realm dominated by a single star to a realm governed by the collective influence of billions of stars and the remnants of their entire life cycles. The composition of the interstellar medium that Voyager 1 is now traversing is of immense interest to astrophysicists. By studying it directly, we can learn about the raw materials from which new stars and planetary systems are born. It contains the chemical fingerprint of our galactic neighborhood, telling a story of stellar nucleosynthesis and supernova enrichment that has unfolded over eons. The particles that now gently buffet the hull of the Voyager spacecraft were forged in distant, long-dead suns. They have traveled across light years of space, carrying with them the history of the galaxy. By sampling this material, we are, in a very real sense, performing an archaeological dig of the Milky Way, uncovering the building blocks of our own cosmic origins. The boundary region, this Wall of Fire, also serves as a cosmic laboratory for the study of plasma physics. The conditions of temperature, density, and magnetic field strength found in the heliosheath are impossible to replicate in any laboratory on Earth. By studying the data from our probes, scientists can test and refine their theories of how plasmas behave under extreme conditions. This has applications far beyond just understanding our solar system. The physics of shock waves, magnetic reconnection, and particle acceleration that we observe in our heliosphere are the same fundamental processes that occur in far more exotic and energetic environments, such as around black holes, in supernova remnants, and within the vast jets of plasma ejected from active galactic nuclei. Our home's boundary is a microcosm of the universe's most dramatic phenomena. One of the more subtle but important aspects of this boundary is its role in mediating the flow of neutral atoms. While interstellar hydrogen is slowed at the hydrogen wall, some of it still penetrates deep into the solar system. As these neutral atoms travel towards the sun, they can be ionized by solar ultraviolet light or by charge exchange with the solar wind. These newly created pickup ions are then swept back outwards with the solar wind, creating another distinct population of energetic particles. Studying the distribution of these interstellar neutrals and pickup ions gives us another powerful tool to diagnose the conditions at the boundary and understand the constant, delicate exchange of matter between our solar system and the galaxy. The name, Wall of Fire, is evocative and captures the immense temperature, but it is ultimately a metaphor. It is not a burning inferno in the chemical sense we understand on Earth. There is no combustion. It is a wall of pure kinetic energy, a boundary defined by the motions of particles in a near-perfect vacuum. It is a structure of immense scale and power, yet it is so diffuse and tenuous that it is completely intangible. This paradox is a recurring theme in astrophysics. The universe is filled with objects and phenomena of unimaginable power: black holes with infinite density, neutron stars with gravitational fields that bend light, that are governed by principles far removed from our sensory experience. The wall is a perfect example of this mind-bending, yet deeply physical, reality. The interaction of the heliosphere with the local interstellar cloud is specific to our current location in the galaxy. In the distant past and in the far future, our solar system will travel through different regions of the interstellar medium. If we were to pass through a much denser giant molecular cloud, the kind from which new stars are born, our heliosphere would be compressed dramatically. The termination shock could be pushed inwards to the orbit of Jupiter, or even closer. The influx of galactic cosmic rays would increase, and the entire chemical and radiative environment of our solar system would change. Understanding our current boundary is therefore a snapshot in a long cosmic journey, providing a baseline against which we can model the past and future evolution of our home's galactic environment. The scale of the heliosheath is difficult to overstate. When Voyager 1 crossed the termination shock in 2004, it was approximately 94 astronomical units from the Sun, or 94 times the distance from the Earth to the Sun. It then spent nearly 8 years traveling through the heliosheath before it finally crossed the heliopause at 121 astronomical units in 2012. This means this chaotic, turbulent buffer region is itself billions of miles thick. It is a testament to the immense power of the solar wind that it can maintain such a vast structure against the pressure of the entire galaxy. It also illustrates the patience required for this type of exploration, where journeys are measured in decades and distances are so great that radio signals take nearly a full day to reach us. There may even be multiple shock waves at this boundary. While the termination shock is caused by the solar wind slowing down, a bow shock is theorized to exist ahead of us, where the interstellar medium itself is disrupted by our motion. Some models suggest that the interstellar plasma is moving at subsonic speeds relative to our heliosphere, which would mean we don't create a sharp bow shock, but rather a more gentle bow wave. Determining whether a bow shock or a bow wave exists is a key goal for a future interstellar probe, as it would tell us fundamental properties about the local galactic environment we are currently traversing. The presence or absence of this outer shock wave is one of the biggest remaining questions in heliophysics. The very concept of a boundary suggests a separation, a distinction between inside and outside. The discovery and characterization of the heliosphere has, in a scientific sense, drawn the borders of our home. It has given us a physical definition for the extent of the sun's direct influence. This is a profound philosophical achievement. For millennia, our world was the Earth. Then it expanded to include the planets. Now we see that our true home is this entire magnetic bubble, this cocoon that travels with us through the Milky Way. The Wall of Fire is not a barrier to keep us in, but the very hull of our ship, and by studying it, we are learning the art of interstellar navigation. The information about this boundary helps us interpret astronomical observations of other stars. When we look at distant stellar systems, we can sometimes see evidence of their astrospheres interacting with their local environments, creating beautiful bow shocks that are visible in infrared or radio wavelengths. Our direct measurements of our own heliosphere provide the ground truth, a detailed physical model that we can then apply to these distant observations. It allows us to understand the physics of what we are seeing light years away. By studying our own backyard in exquisite detail, we gain the tools to comprehend the processes shaping entire galaxies. The local becomes the key to the universal. It is a beautiful piece of cosmic symmetry that the sun, the source of light and life for our system, is also the architect of its primary shield. The very same solar wind that can cause geomagnetic storms and disrupt communications is, on a grander scale, our principal defender against even more hazardous galactic radiation. The sun's constant outflow of energy creates the conditions for life and simultaneously protects that life from external threats. This delicate balance, this dual nature of stellar influence, is a powerful reminder of the intricate and often counterintuitive web of cause and effect that governs the cosmos. The wall of fire is not a destructive force, but a protective one, born from the very heart of our solar system. The particles within the heliosheath are trapped, rattling around inside this magnetic buffer zone for years before they either escape into interstellar space or are circulated back inwards. This creates a unique particle population that is a mixture of slowed solar wind and interstellar pickup ions. These particles are continually re-accelerated by the turbulence and shock waves within the sheath, creating what are known as anomalous cosmic rays. These are particles with energies between the solar wind and the much higher energy galactic cosmic rays. Their origin was a long-standing mystery until it was realized they are born right here, in the outer regions of our own heliosphere, accelerated within the very structure of our cosmic shield. The Voyager probes taught us that this boundary is not a static, smooth surface. They detected turbulence and pressure waves rippling through the heliosheath. Furthermore, they found that the heliopause itself breathes in and out, and that large-scale solar events, like coronal mass ejections, can send shock waves propagating all the way to the edge of the system, temporarily pushing the boundary further into interstellar space. It is a dynamic, living interface. It is less like a solid wall and more like the surface of an ocean, with tides, waves, and storms. These dynamics are crucial to understanding the minute-by-minute, year-by-year regulation of the galactic radiation that reaches our planet. A key takeaway from this exploration is the primacy of magnetic fields in shaping the universe on a large scale. While gravity governs the orbits of planets and stars, it is the invisible force of magnetism that dictates the structure of the interstellar medium and the boundaries between stellar systems. The heliosphere is, at its heart, a magnetic bubble. Its ability to deflect charged particles, both from the solar wind and the galaxy, is a purely electromagnetic phenomenon. The wall of fire and its associated structures are a magnificent testament to the power of cosmic magnetism, a force that sculpts nebulae, guides stellar winds, and creates the protective cocoons necessary for worlds like ours to exist. The journey of a single proton from the sun's corona to this distant boundary is an epic in itself. Ejected at 1,000,000 miles per hour, it travels for months or even years, crossing the orbits of all the planets. It then collides with the termination shock, its velocity plummeting as its energy is converted into heat. It spends years more rattling around in the turbulent heliosheath, its path dictated by tangled magnetic fields. Finally, it may cross the heliopause and drift into the true interstellar void, forever leaving its home star behind. Every single particle in the solar wind participates in this grand process, collectively maintaining the structure that defines and defends our place in the galaxy. Could a human ever travel to this boundary and witness it? Under current technology, such a journey is impossible. The decades-long travel time and the harsh radiation environment present insurmountable challenges, but it remains a tantalizing prospect for the distant future. To float in the heliosheath, To be in a place where the particles around you are 30,000 degrees, yet to feel only the profound cold of the void, would be the ultimate sensory experience of cosmic physics. It would be a pilgrimage to the edge of our solar system, a chance to stand on the shore of the interstellar ocean and see our sun as just another star, its light and influence finally giving way to the grandeur of the Milky Way. It is important to remember that this entire structure, as vast as it is itself tiny on a galactic scale. The heliosphere extends perhaps 100 to 200 astronomical units from the Sun. The nearest star, Proxima Centauri, is over 268,000 astronomical units away. Our entire solar system, including its vast protective bubble, is just a minuscule speck drifting in the enormous void between stars. This perspective is humbling. It underscores the immense isolation of our planetary system, but it also highlights the incredible preciousness of the shield that our star provides. In the grand emptiness of the galaxy, our sun has forged a small, warm, and protected harbor, and the Wall of Fire is the lighthouse that marks its entrance. The ongoing study of this boundary is a truly international and multi-generational endeavor. It began with the theoretical physicists who first conceived of the heliosphere, was advanced by the engineers who built the Voyager probes, and is now carried forward by scientists analyzing data that has been traveling for nearly a day to reach them. Soon, a new generation will design the interstellar probe that will continue this legacy of exploration. It is a perfect example of how science operates. A slow, meticulous, and collaborative process of building knowledge, with each generation standing on the shoulders of the giants who came before, all driven by the fundamental human need to understand our place in the universe and to see what lies beyond the next horizon. Ultimately, the Wall of Fire is not a place of danger but a place of transformation. It is where the familiar material of our solar system is reprocessed and mixed with the exotic material of the galaxy. It is where the laws of our sun finally yield to the laws of the interstellar medium. Passing through it, as the Voyager probes have done, is a rite of passage, transforming a vessel from a mere planetary probe into a true interstellar messenger. It marks the point of no return, the final farewell to the gravitational and magnetic embrace of the star that gave it birth. It is a testament to the idea that all boundaries, even those of cosmic scale, are not just endings, but also beginnings of a new and far grander journey. The light from our sun takes about 18 hours to travel to the heliopause. This means when we look at data from this boundary, we are seeing the result of an interaction that happened almost a full day ago. This time delay is a constant reminder of the sheer scale of the system we inhabit. We are always looking into the past. The data arriving today on Earth from Voyager 1 tells of the conditions it experienced yesterday. Exploration on this scale requires a mental adjustment, an acceptance of the finite speed of light as a fundamental barrier to real-time communication. It imparts a sense of patience and a deep appreciation for the vast, silent distances that separate the worlds and their ultimate frontier. The neutral particles that make it through the heliosphere, like hydrogen and helium from the interstellar medium, provide a direct sample of our galactic neighborhood. Instruments like the ultraviolet spectrograph on Voyager and other Earth-orbiting satellites can study how this neutral gas scatters ultraviolet light from the sun and other stars. By observing how this light is filtered and absorbed, we can deduce the composition, temperature, and velocity of the material our solar system is currently plowing through. This gives us an independent way to probe the interstellar medium, complementing the direct measurements from probes and providing a more complete picture of the ocean our heliosphere is sailing upon. One can think of the entire heliosphere as the sun's extended atmosphere. Just as Earth has its troposphere and stratosphere, the sun's atmosphere doesn't end at its visible surface. It extends outwards via the corona and the solar wind to fill a vast region of space. The heliopause is the equivalent of our planet's magnetopause, the final boundary where our magnetic field dominates. The He Wall of Fire in the heliosheath is an extreme form of atmospheric layer, a place where energy is deposited and physical conditions change dramatically. Viewing our solar system through this atmospheric lens helps to conceptualize it not as empty space with objects in it, but as a single, coherent, nested system of energetic layers, with the sun at its core. The cosmic rays that are filtered by this boundary originate from some of the most violent events in the universe. A A single cosmic ray proton striking our instruments at the edge of the solar system may have begun its journey millions of years ago in a supernova explosion thousands of light years away. It would have been accelerated to near light speed and then spent eons ricocheting off galactic magnetic fields before, by pure chance, arriving at our doorstep. The heliosphere stands as the final gatekeeper in this ancient and violent journey. Studying which particles get through and how their energy is changed by the passage tells us a great deal about both the galaxy's most powerful accelerators and the effectiveness of our own local shield. The energy required to sustain this entire structure is immense, all of it supplied by the Sun. Our star loses about 1 million tons of mass every single second to the solar wind. While this is a tiny fraction of the Sun's total mass, over billions of years it adds up. This constant outflow of mass and energy is what powers the entire heliospheric system, from the supersonic wind to the turbulent heliosheath. It is a colossal, continuous expenditure of stellar energy to maintain a protective bubble trillions of miles in diameter. The 30,000-degree temperature at its edge is a direct manifestation of this dissipated energy, a final, glowing testament to the power of the star that lies at the system's heart. This exploration into the nature of our solar system's boundary has fundamentally changed our perception of space. It is not a passive backdrop for planetary motion. It is an active, dynamic medium. It is a place of invisible walls, magnetic turbulence, shock waves, and extreme temperatures. It is filled with a constant flow of particles both from within and without. The discovery of the heliosphere's true complexity has transformed the void into a vibrant, physical environment. It has given us a new appreciation for the intricate connection between our Sun, our planet, and the vast, majestic galaxy through which we all journey together, forever shielded by this distant, invisible, and utterly remarkable wall of fire. As we conclude this deep analysis of the heliosphere's structure, we are left with a sense of profound and intricate order. A series of nested boundaries, each governed by precise physical laws, separates our cosmic home from the raw galactic environment. The supersonic solar wind, the termination shock, the turbulent heliosheath, and the final heliopause all work in concert to form a dynamic and resilient shield. The so-called wall of fire is not a destructive anomaly, but a natural and necessary consequence of this grand interaction. It is the signature of our passage through the cosmos, a warm glow at the edge of the familiar, beckoning us to understand ever more deeply the subtle mechanics of our universe. The local interstellar cloud through which we currently journey is but a wisp of gas and dust within a much larger structure known as the local bubble. This is a vast, peanut-shaped cavity in the interstellar medium, roughly 300 light-years across, which was likely cleared out by a series of supernova explosions millions of years ago. The gas inside this bubble is significantly less dense and hotter than the galactic average. Our heliosphere, with its fiery wall, is therefore interacting with a very specific and relatively benign cosmic neighborhood. The nature of our boundary, its size and temperature, are a direct consequence of this local environment. Were we traveling through one of the dense spiral arms of the Milky Way, our shield would be a far different and likely more compressed and turbulent structure. It is essential to visualize the galactic magnetic field, the silent and unseen force that drapes itself around our heliosphere. This is not the field of a single object, but the cumulative field generated by the motions of plasma throughout the entire Milky Way. It threads through interstellar clouds, guides the paths of cosmic rays, and dictates the fundamental shape of stellar astrospheres. The ibex ribbon is our first direct glimpse of this interaction, showing us how this external field presses upon our own, creating a complex magnetic topology. Our heliosphere does not simply push the interstellar medium aside. It engages in a magnetic negotiation, a silent dance of forces that shapes its very existence and defines its orientation relative to the galactic plane. The journey of our solar system through the galaxy is not a straight line but a grand, stately orbit around the galactic center, a voyage that takes roughly 230 million years to complete. During this galactic year, we bob up and down through the plane of the Milky Way. This means that over immense timescales, our heliosphere is subjected to dramatically different environments. We pass through dense molecular clouds, regions of intense star formation, and the sparse voids between the spiral arms. Each passage would profoundly alter the nature of our protective bubble and the wall of fire at its edge. The boundary we observe today is but a momentary snapshot in a multi-billion-year history of constant adaptation to an ever-changing cosmic climate. The Voyager probes now drifting through this interstellar medium represent more than just scientific instruments. They are humanity's first true artifacts of the galaxy. On board each spacecraft is a golden record, a gold-plated copper phonograph disc containing sounds and images selected to portray the diversity of life and culture on Earth. There are greetings in 55 languages, pieces of music from different eras and cultures, and images of our world and our species. It is a message in a bottle thrown into the cosmic ocean, a hopeful testament designed to survive for 1 billion years. Long after our sun has died, these silent probes may be the only remaining evidence that we ever existed, their passage through the ancient wall of fire, marking the start of their eternal, lonely mission. The longevity of the Voyager mission is an engineering marvel. Launched in 1977 with technology that is primitive by today's standards, their onboard computers have less memory than a modern car key fob. They have survived for decades in the harsh radiation environment of space. Their power comes from the slow decay of plutonium-238 in their radioisotope thermoelectric generators. This fading power source is the ultimate determinant of their lifespan. Engineers on Earth perform a delicate balancing act, shutting down non-essential heaters and instruments one by one to conserve the last vestiges of power for the most critical systems. Each bit of data received is a precious gift from the past, a faint whisper from a machine that has become a legend. The crossing of the heliopause by Voyager 1 was not just a scientific milestone, it was a profound moment of transition. For all of human history, every object we have ever created existed within the cradle of the sun's influence. Voyager 1 was the first to leave the nest. In that moment, it ceased to be a probe of our solar system and became a probe of the galaxy. It is now being touched by winds from other stars and bathed in light that has traveled for centuries. It is the farthest reach of the human hand, a physical presence in a realm we had previously only known through the faint glimmer of starlight. Its journey through the hot boundary layer was the final, fiery test before it could achieve this monumental status. The golden record contains 116 images encoded in analog form, depicting mathematical and physical quantities, the solar system, our DNA, and various facets of human life. It also carries the brainwave activity of Ann Druyan, the creative director of the project, who meditated on humanity's history and the meaning of love, as her neurological signals were recorded. This adds a deeply personal and poignant layer to the message. It is not just a collection of facts, but a representation of human consciousness itself, cast out into the great unknown. The probes are therefore not just machines. They are poetry in motion, carrying a piece of our collective soul on their journey beyond the fiery edge of our world. The future trajectory of the Voyager probes is one of serene, perpetual motion. Having escaped the sun's gravity, they are now bound to the galaxy itself. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445. In around 296,000 years, Voyager 2 will pass 4.3 light-years from Sirius, the brightest star in our night sky. Their journeys are on timescales that dwarf human civilization. They are our silent, enduring emissaries, sailing on the currents of the Milky Way. Their power long since faded, but their purpose as bearers of our story enduring for eons. They are the ultimate pioneers, having navigated the turbulent waters of the heliosheath and passed through the invisible wall into the great beyond. The success and longevity of the Voyager program has laid the foundation for an even more ambitious concept: a dedicated interstellar probe. This mission, currently in the early planning stages, would be humanity's first explicit step in a multi-generational effort to explore our local galactic neighborhood. It would be designed from the ground up for this purpose, optimized for speed and instrumented to answer the specific questions that Voyager raised. Its goal would not be to simply reach interstellar space, but to characterize it, to understand its structure, its magnetic fields, and its relationship with our own heliosphere in unprecedented detail. It represents the next logical chapter in the human story of exploration. To reach the interstellar medium in a human lifetime, a future interstellar probe would need to achieve incredible speeds, far faster than any previous spacecraft. Engineers are exploring several options to achieve this. One possibility is to use a powerful new rocket, like NASA's Space Launch System combined with a Jupiter gravity assist. An even more effective method would be to perform a solar orbit maneuver, a powered flyby that slingshots the probe incredibly close to the Sun. By firing its engine at the point of maximum gravitational potential, the probe could achieve speeds exceeding 10 times that of the Voyager craft, potentially reaching the Wall of Fire in the heliopause in less than 2 decades, turning a half-century journey into a focused scientific investigation. The scientific payload on a future interstellar probe would be a marvel of modern technology. It would include advanced plasma sensors to measure the properties of the solar wind and interstellar medium with exquisite precision. It would carry magnetometers capable of untangling the complex magnetic dance at the heliopause. Most importantly, it would feature sophisticated energetic neutral atom imagers, direct descendants of the instruments on IBEX, designed to create a high-definition movie of the heliosphere's boundary as the probe travels through it. This would finally allow us to understand the true nature of the mysterious IBEX ribbon and solve the puzzle of the heliosphere's overall shape, be it a comet, a croissant, or a simple bubble. One of the profound questions an interstellar probe could answer is whether our local interstellar environment is typical for the galaxy. Is the local bubble a common feature? Is the density and temperature of the interstellar medium we are in representative of other regions? By traveling hundreds of astronomical units into pristine interstellar space, the probe could sample the galactic environment far from the contaminating influence of our Sun. This would provide a crucial baseline for astrophysics, allowing us to better interpret observations of other star systems and to refine our models of star formation and galactic evolution. We would finally have a true, unbiased sample of the raw material of the Milky Way. This entire exploration forces us to contemplate our cosmic solitude. The heliosphere, our protective shield, is also a wall of separation. It defines the boundary of our home, but in doing so, it highlights the sheer, unimaginable emptiness that lies beyond it. The nearest star is more than 20,000 times farther away than the edge of our own heliosphere. The discovery of this vast, hot, and complex boundary layer reinforces the idea that we inhabit a precious, isolated oasis in an immense cosmic desert. This realization is not a cause for despair, but for a deeper appreciation of our world and the intricate cosmic mechanisms, like the Wall of Fire, that make our existence possible. The fiery wall at the edge of our system can be seen as a metaphor for the limits of human knowledge. For centuries, our understanding ended at the orbit of the outer planets. With the Voyager probes, we pushed that boundary outward, only to find a new, more complex frontier waiting for us. Every act of exploration reveals a new and more subtle horizon. The universe seems to be structured in this way, with layers of reality unfolding as our tools and our understanding grow more sophisticated. The heliosphere teaches us that the cosmos is not a simple void to be crossed, but a rich tapestry of interacting forces and structures, and that the journey of discovery is an infinite one. There is a profound aesthetic elegance to the physics of the heliosphere. It is a self-regulating system, born from the simple outflow of particles from a star, that naturally organizes itself into a complex, multi-layered structure of shocks and boundaries. It is a perfect illustration of how simple physical laws, applied over immense scales of time and space, can give rise to emergent properties of incredible complexity and beauty. The Wall of Fire is not a random occurrence. It is a necessary and predictable consequence of a star moving through a magnetized medium. Its existence is a testament to the fundamental order and mathematical harmony that underpins the apparent chaos of the cosmos. The light from all the other stars in the galaxy must pass through this boundary region to reach us. While the effect is subtle, the plasma in the heliosheath and the hydrogen wall can scatter and absorb light at certain frequencies. This means that our view of the universe is subtly filtered by our own protective bubble. A future interstellar probe, once it passes into the pristine medium beyond, will be able to look back and measure this filtering effect directly. It will also be able to conduct astronomy from a truly interstellar perspective, free from the zodiacal light and radio noise generated within our own solar system. It will open a new, clearer window onto the cosmos. The concept of a wall implies something solid and impassable, but the wall of fire is the opposite. It is a permeable membrane. It blocks the majority of low-energy cosmic rays, but it allows high-energy ones to pass through. It slows and piles up neutral hydrogen, but it allows some of it to trickle in. It is a dynamic filter, not a static barrier. This constant regulated exchange between our solar system and the galaxy is vital. It reminds us that we are not truly separate from the universe, but deeply connected to it. We are constantly breathing in the material of the interstellar medium and are in turn breathing out the solar wind, contributing to the complex ecosystem of the galaxy. Reflecting on this discovery cultivates a unique state of contemplative calm. To know that we are cocooned within this vast, warm, and protective sphere changes our relationship with the night sky. The stars are not just distant points of light in a cold void. They are beacons in a physical medium through which we are sailing. The darkness between them is not empty, but filled with the very substance of the galaxy, pressing against our invisible shores. This knowledge transforms the cosmos from a static diorama into a living, breathing environment, and our place within it becomes not one of passive observation but of active participation in a grand cosmic journey. The heliosphere also protects the very chemistry of our solar system from being altered. The interstellar medium contains dust grains and complex molecules formed in other stellar systems. Without the filtering effect of the heliopause and the outward pressure of the solar wind, this material could penetrate much deeper into our system, potentially altering the composition of atmospheres on outer planets and moons. The boundary acts as a form of cosmic gatekeeper, ensuring that the chemical evolution of our solar system proceeds in relative isolation, allowing the unique conditions that led to life on Earth to develop without constant external contamination. The wall is not just a radiation shield, but a chemical one as well. Consider the silence. For all the talk of a wall of fire and termination shocks, these events unfold in a near-perfect vacuum, in utter and complete silence. There is no medium to carry sound waves. The sonic boom of the solar wind is a mathematical concept, not an audible one. The 30,000-degree temperature is a silent vibration of particles. This juxtaposition of immense power and profound silence is at the heart of the awe that space inspires. It is a realm of unimaginable energies and epic collisions, all taking place in a theater of absolute stillness. This knowledge encourages a quiet, deep reverence for the unseen forces that shape our existence. The study of cosmic dust particles provides another window into this distant region. Tiny dust grains from the interstellar medium are able to penetrate the heliosphere. Their trajectories, however, are influenced by the heliospheric magnetic field and the pressure of solar radiation. By studying the distribution and motion of these interstellar dust particles, with spacecraft like Ulysses and Cassini, we can infer properties of the boundary they crossed. These tiny messengers carry with them information about the structure of the magnetic fields at the frontier and the direction of the interstellar flow. They are the smallest and most numerous probes of the galaxy, constantly raining down upon us and telling their story to our sensitive instruments. The entire heliospheric system can be thought of as a single, giant particle detector, and our spacecraft inside it are the sensors. When a high-energy galactic cosmic ray is deflected by the magnetic fields in the heliosheath, its path is altered. When a solar energetic particle is accelerated at the termination shock, its energy is boosted. By observing the particles that arrive at Earth and at our various probes, we can reconstruct the journey they took through this vast magnetic labyrinth. We are using the entire solar system as a laboratory to understand the fundamental physics of particle acceleration and transport, processes that are crucial for understanding the most energetic phenomena in the universe. The future of heliophysics lies in coordinated, multi-point observations. Imagine a fleet of small probes scattered throughout the heliosphere, from the orbit of Earth to the heliosheath itself. By observing the same solar event, like a coronal mass ejection, as it propagates outwards and interacts with the various boundaries, we could build a true, three-dimensional dynamic picture of our cosmic shield. This space weather forecast would not just predict effects near Earth, but would tell us how our entire system responds to the Sun's activity. This is the long-term vision, to move from single-point exploration to a comprehensive, system-wide understanding of our home and the cosmos. The discovery of the Wall of Fire has a subtle influence on our collective imagination. It provides a new landscape for science fiction, but more importantly, it enriches our shared, factual understanding of our cosmic environment. It is a powerful piece of knowledge that adds texture and detail to our mental map of the universe. It replaces the simple, sterile vision of a vacuum with a complex, energetic, and protective boundary. This kind of scientific discovery slowly permeates culture, fostering a deeper and more accurate sense of wonder. It reminds us that the universe is not only stranger than we imagine, but stranger than we can imagine. Let us contemplate the particles themselves. A proton within the Wall of Fire is moving at hundreds of kilometers per second. It is a single, fundamental constituent of matter, yet it possesses an energy that, on its scale, is immense. It is part of a collective so sparse that it exerts no meaningful heat, yet so vast that it defines the boundary of a star system. To appreciate this phenomenon is to appreciate the duality of the universe, where the microscopic behavior of individual particles gives rise to macroscopic structures of breathtaking scale and complexity. The wall is a monument built from the silent, high-speed dance of countless, individual atomic nuclei, a symphony of kinetic energy at the edge of the void. This exploration of our solar system's edge is a form of self-discovery. By defining the boundaries of our home, we are, in essence, defining ourselves in a cosmic context. Just as early explorers mapping the continents of Earth gave humanity a new sense of its global identity, explorers mapping the heliosphere are giving us a new sense of our solar identity. We are the inhabitants of this bubble, the children of this particular star. This knowledge provides a unifying perspective, a recognition that all of humanity shares this one celestial vessel on its long and silent journey through the Milky Way. The Wall of Fire is our collective cosmic shoreline. The shape of our heliosphere may even be influenced by the gravitational pull of the galactic plane. As we orbit the center of the Milky Way, we are also oscillating vertically, passing through the dense central disk of stars and gas every 30 million years or so. The ambient pressure, magnetic field strength, and radiation environment change during this passage. Some theories suggest the heliosphere may flatten or become distorted as it passes through the galactic plane, responding to the tidal forces of the galaxy itself. Our shield is therefore not only shaped by the local interstellar wind, but potentially by the grand architecture of the Milky Way as a whole, a humbling reminder of the nested scales of influence that govern our existence. Understanding the heliosphere is also critically important for future interstellar travel, however distant that dream may be. Any craft leaving our solar system will have to pass through this turbulent region. It will need to be shielded against the radiation from anomalous cosmic rays and be able to navigate the complex magnetic fields. The data from the Voyager probe serves as the first hazardous environment report for future travelers. They have charted the currents and the weather at the edge of our shores, providing the first navigational maps for the sea of interstellar space. The Wall of Fire is the first storm any future starship will have to weather on its way to the stars. The beauty of this discovery lies in its completeness. It connects the nuclear fusion in the heart of our sun to the tenuous gas lying light years away. The entire heliospheric system is a single, unbroken chain of cause and effect. The sun's furnace creates the corona. The corona generates the solar wind. The solar wind inflates the heliosphere. The heliosphere's motion creates a boundary, and the boundary heats the plasma to tens of thousands of degrees. It is a holistic and deeply interconnected system. To understand one part is to gain insight into all the others. This interconnectedness is a hallmark of the natural world, and the heliosphere is perhaps the largest and most elegant example of it we can directly observe. The Voyager spacecraft are now so far away that their faint signals are easily lost in the background noise of the cosmos. To hear their whispers, we rely on the massive radio antennas of the Deep Space Network. These giant, sensitive ears located around the globe are pointed precisely at the patch of sky where the probes are, listening patiently for the trickle of data. This act of listening across such a vast distance is a profoundly hopeful one. It is an expression of our enduring connection to our creations and our unyielding desire for knowledge from the frontier. As long as we are listening, the mission is alive and the journey of discovery continues. The plasma at the solar system's edge is so tenuous that it behaves in ways that defy our intuition, which is built on experiences with dense gases and liquids on Earth. In the heliosheath, waves can travel through the plasma that have no terrestrial analog. These Whistler mode waves, for instance, are electromagnetic oscillations that are guided by the magnetic field lines. The Voyager probes have detected the faint hiss of these waves, a sort of sound of the plasma sea. By studying the frequency and intensity of this plasma wave activity, scientists can diagnose the density of the medium the probes are traveling through, confirming, for example, the dramatic jump in density upon crossing into interstellar space. It is worth considering that if intelligent life exists on a planet orbiting a nearby star, they too would be encased in their own astrosphere, their own version of the heliosphere. Their probes would have discovered their own wall of fire, a boundary defined by their star's wind and their local interstellar cloud. The study of stellar bubbles might one day become a part of SETI, the search for extraterrestrial intelligence. By observing the detailed structure of a star's astrosphere, we might be able to infer properties about its stellar wind and its galactic environment, adding another layer of data to our assessment of its potential to host life. These cosmic shields may be a universal prerequisite for the evolution of biology. The discovery reminds us that the most significant features of the universe are often invisible. We cannot see the solar wind, the magnetic fields, or the termination shock with our eyes. The 30,000-degree plasma of the heliosheath emits no visible light. This entire magnificent structure is completely transparent. It can only be perceived through the specialized senses of our robotic probes, their particle detectors, their magnetometers, their plasma wave instruments. This is a profound statement about the nature of reality. The universe that is revealed to our biological senses is only a tiny fraction of what truly exists. To truly see the cosmos, we must build new eyes and learn to interpret their strange and wonderful new senses. The heliosphere is our shield, but it is not perfect. Occasionally, a powerful supernova explosion can occur relatively close to our solar system, within a few hundred light-years. Such an event would unleash a devastating flood of high-energy cosmic rays, powerful enough to overwhelm our magnetic defenses. The radiation could potentially damage our planet's ozone layer and trigger a mass extinction event. Some scientists speculate that such a nearby supernova may have occurred a few million years ago. Our wall of fire is a formidable guardian against the everyday galactic weather, but it cannot protect us from the truly catastrophic cosmic storms, reminding us of the violent and unpredictable nature of the universe we inhabit. The journey of discovery that led to our understanding of the heliosphere was a slow and patient one. It began with early observations of comets, whose tails were seen to always point away from the sun, providing the first hint of a continuous solar outflow. It was formalized in the 1950s by Eugene Parker, who mathematically predicted the existence of the supersonic solar wind. His theories were initially met with skepticism. It was not until the first space probes of the 1960s flew beyond Earth's magnetosphere that his predictions were directly confirmed. The story of the heliosphere is a perfect example of the scientific method, a bold theory followed by decades of painstaking experimental work to verify and refine it. We can think of the interstellar medium as having its own form of weather, with high-pressure regions of dense gas and low-pressure regions of sparse plasma. Our heliosphere expands and contracts as it moves through these different weather systems. The wall of fire at its edge would glow hotter and brighter as we plow through a dense cloud, and it would cool and dim as we enter a void. This galactic forecast changes over millions of years, but it has profound implications for the long-term evolution of our solar system. The climate on Earth, over geological time, may be subtly influenced by the cosmic weather through which our entire solar system is traveling. The wall of fire discovery instills a sense of deep time. The heliosphere has existed for the entire 4.6 billion-year history of our solar system. It was present when the Earth was a molten ball of rock, when the first single-celled organisms emerged, and as life evolved into the complex biosphere we see today. It has been our silent, constant guardian throughout our planet's entire history. This structure connects us to the very formation of our world. We are living within a fossil of the solar system's birth, a bubble that has been maintained, unbroken, for eons, a testament to the stability and endurance of our star. The knowledge of this boundary enriches our inner world. It provides a grander stage upon which to contemplate our existence. To stand under the night sky and to know that you are looking out from within a vast, warm bubble surrounded by a diffuse wall of fire is to feel both protected and profoundly connected to the cosmos. It is a fact that inspires a quiet, internal awe, a sense of wonder that is both intellectual and emotional. It does not require a telescope to appreciate, only a moment of quiet contemplation. This is the ultimate gift of science, not just to explain the world, but to deepen our experience of it. The future of this field of study is bright. With new missions like the Interstellar Mapping and Acceleration Probe IMAP on the horizon, we are poised to gain an even more detailed understanding of this boundary. IMAP will build on the legacy of IBEX, creating far more detailed maps of the energetic neutral atoms that paint a picture of our heliosphere's interaction with the galaxy. Each new mission, each new instrument peels back another layer of the mystery, revealing a universe that is consistently more complex, more interconnected, and more beautiful than we had previously imagined. The exploration of our home's final frontier has only just begun. Let us imagine standing on a hypothetical world orbiting the very edge of the heliosheath. From this vantage point, the sun would be just another bright star. In one direction, you would see the familiar constellations of our solar system. In the other, you would face the unadulterated glare of the Milky Way, seen through the diffuse glow of the hydrogen wall. You would be standing on the shore between two worlds, the realm of the sun and the realm of the galaxy. It is a place of profound duality, a boundary that exists not as a physical wall, but as a subtle shift in the balance of power between a single star and the 10 billion stars of its home galaxy. The temperature of the hydrogen wall, that stunning 30,000 degrees, is ultimately a legacy of starlight. The neutral hydrogen atoms that pile up at our frontier are energized by the ultraviolet radiation streaming from hot, young stars located elsewhere in our galactic neighborhood. It is the light from these other distant suns that helps to heat the plasma at our boundary. This is a beautiful and profound connection. The structure of our own home, the very temperature of its outer wall, is directly influenced by the lives and light of stars that are light years away. It is a tangible reminder that in the galaxy, nothing is truly isolated. We are all part of a single, luminous ecosystem. The Voyager probes continue to measure the properties of the interstellar magnetic field as they travel further from the Sun. These are the first and only direct measurements of the magnetic field between the stars. They have revealed that the field is stronger and more complex than many models had predicted. It appears to be pressed up against the heliopause, draping around our bubble like fabric. By tracking how this field changes with distance, we are piecing together a map of the magnetic superstructure of our corner of the galaxy, a structure that holds the key to understanding how stars form, how cosmic rays travel, and how the galaxy itself evolves over time. The discovery and ongoing exploration of the heliosphere is a story about the power of persistence. The Voyager probes were launched over 4 decades ago. The scientific careers of many researchers have been dedicated to their long and patient journey. The data arrives not in a sudden flash of insight, but as a slow, steady trickle that has gradually built up our understanding over decades. It is a testament to long-term thinking and the human capacity to invest in endeavors whose greatest rewards may not be realized for a generation. It is science at its most patient, its most tenacious, and ultimately its most profound. The heliosphere is a system in near-perfect pressure balance. The outward thermal pressure of the hot solar wind plasma is constantly pushing against the inward pressure of the interstellar medium, which is a combination of thermal pressure, plasma pressure, and the pressure exerted by the magnetic fields and cosmic rays. The heliopause is the surface where these two opposing forces find equilibrium. It is a boundary defined by a delicate cosmic stalemate. If the pressure from the galaxy were to increase, our bubble would shrink. If the solar wind were to strengthen, it would expand. This constant, silent pressure struggle is what maintains the integrity of our home in the cosmos. As we continue to refine our understanding of this boundary, we gain a new appreciation for the fragility of our world. While the heliosphere is a powerful shield, it is also a thin and tenuous one relative to the scale of the galaxy. Its existence depends entirely on the continued, stable output of our Sun. This reinforces the Goldilocks nature of our situation. We are not only on a planet at the right distance from its star, but we are within a star system that has a sufficiently strong stellar wind, traveling through a galactic neighborhood that is sufficiently benign. The conditions for life are a series of nested dependencies, from the planetary scale to the atmospheric, and, as we now know, all the way to the heliospheric. The exploration of the heliosphere represents a shift in human consciousness. For our entire history, exploration has meant going to a place, a new continent, another planet, a moon. But this is different. This is the exploration of a process, of a region defined not by solid matter, but by the interaction of invisible forces. It is a more abstract and more subtle form of discovery. It requires us to think in terms of fields, plasmas, and shock fronts. It is pushing not just the boundaries of our technology, but the boundaries of our intuition, forcing us to develop a new, more comprehensive way of seeing our place in the universe. The Wall of Fire is a source of cosmic humility. It demonstrates that our most basic, earth-bound concepts like temperature can have profoundly different meanings in the wider universe. It shows us that even our own backyard is filled with phenomena that challenge our intuition and stretch the limits of our language. Every new discovery in astrophysics seems to carry this same lesson. The universe is not obligated to conform to our common sense. To understand it, we must be willing to let go of our preconceptions and embrace the strange and paradoxical nature of reality on a cosmic scale. Let's consider the heliotail, the long, trailing wake of our solar system. For a long time, this was thought to be a single, comet-like tail. However, recent data suggests it may be split into two distinct lobes, shaped like a four-leaf clover, due to the complex interaction of the solar and interstellar magnetic fields. This structure is filled with slow-moving plasma and acts as a long, turbulent corridor through which interstellar material can be funneled. Understanding the structure of our own wake is not just an academic curiosity. It is a key part of the puzzle of how star systems interact with the galaxy and exchange matter with it over long periods of time. This entire grand structure, from the sun's corona to the distant heliopause, is fundamentally made of light. The energy is born from fusion, creating photons. The photons heat the plasma. The plasma flows outward as the solar wind. The solar wind's kinetic energy is converted back into thermal energy at the termination shock, creating the hot boundary. It is all a cascade of energy, originating from the conversion of matter into light in the core of our star. The Wall of Fire is the final, most diffuse, and most distant manifestation of the sun's inner fire, a faint echo of the stellar furnace that makes our very existence possible. In the final analysis, the story of the heliosphere is the story of home. It is the scientific narrative of how our small corner of the cosmos is defined and protected. The discovery of its fiery, multi-layered boundary does not make space seem more hostile, but rather makes our own system seem more intricate, more robust, and more precious. It gives us the true measure of our celestial harbor. To look upon the cosmos with this knowledge is to be filled with a profound sense of gratitude for the silent, complex, and beautiful physics that shield our world on its endless journey through the night. Let us delve deeper into the phenomenon of anomalous cosmic rays, or ACRs. These particles are a unique population born within our own solar system, yet possess energies far exceeding that of the solar wind. They originate as neutral interstellar atoms, like hydrogen or helium, that drift into our heliosphere. Deep inside, near the sun, they are ionized, losing an electron. Now charged, they are picked up by the solar wind's magnetic field and carried at tremendous speed towards the outer solar system. When the stream of particles hits the termination shock, some are accelerated to incredible energies through a process called shock acceleration. These newly energized particles, the ACRs, then propagate throughout the heliosphere. They are a signature of our boundary, a local brand of cosmic ray forged in the fiery chaos of the termination shock. The chemical composition of the interstellar medium that Voyager 1 is now directly sampling is a crucial piece of our cosmic puzzle. It is the end product of billions of years of galactic stellar evolution. The hydrogen and helium were formed in the Big Bang, but heavier elements, carbon, oxygen, iron, were forged in the nuclear furnaces of countless stars and then violently dispersed into space via supernova explosions. By measuring the precise abundances of these elements in our local galactic neighborhood, we are reading a chapter of the Milky Way's history. This data allows us to test our theories of stellar nucleosynthesis and understand the chemical environment from which the next generation of stars and planets, including perhaps another Earth, will eventually form. An essential tool in this exploration has been the use of radio astronomy to track the Voyager spacecraft. The signals from the probes are now incredibly faint, weaker than a single watt, less than the power of a refrigerator light bulb, spread over the immense distance of billions of miles. Yet the massive 70-meter antennas of the Deep Space Network can detect them. But beyond simple tracking, these radio signals themselves are a scientific instrument. As the signal from Voyager 1 passed through the interstellar plasma after crossing the heliopause, scientists could detect subtle changes in its frequency. These variations allowed them to measure the density of the plasma, providing the definitive, smoking gun evidence that the probe had truly entered a new, denser cosmic medium. The very shape of the termination shock is likely not a perfect sphere. As the solar wind expands outwards, its properties are not uniform. Fast streams of solar wind, originating from coronal holes on the Sun, can catch up to slower streams, creating massive merged interaction regions. These large-scale structures in the solar wind propagate outwards and can cause the termination shock to become distorted and dynamic. It is likely a rippling, uneven surface that moves in and out in response to the Sun's activity over its 11-year cycle. The wall of fire is therefore not a steady, constant glow, but more like a flickering flame. Its intensity and location shifting in a complex dance dictated by the ever-changing breath of our star. Our heliosphere can be thought of as an archaeological site, containing layers of history. The solar wind takes months to years to travel from the Sun to the heliopause. This means that the plasma found in the heliosheath at any given time is a record of the Sun's activity from years prior. By studying this plasma, we are looking at a history of solar cycles, a record of past solar flares and coronal mass ejections that have been preserved in this distant, turbulent reservoir. A future interstellar probe could read these layers like the rings of a tree, reconstructing the Sun's past behavior and giving us a more complete understanding of the long-term patterns that govern its influence on the solar system. The interaction at the heliopause is not just one of pressure, but also of fluid dynamics. Two distinct plasmas, the solar wind and the interstellar medium, are flowing past each other. This can create what is known as a Kelvin-Helmholtz instability, the same phenomenon that creates the beautiful, curling patterns when wind blows over water. It is possible that the surface of the heliopause is not smooth, but is roiled by these immense, slow-motion waves and vortices. These instabilities could cause the boundary to become leaky, allowing interstellar plasma to mix more readily into our heliosheath and solar wind particles to escape into the galaxy. Our cosmic bubble may have a far more intricate and dynamic surface than we can possibly imagine. It is a profound thought that every second we are moving through about 230 kilometers of interstellar space. Our entire solar system, cocooned in its heliosphere, is a vessel on a relentless journey. We are not static observers of the universe, but active participants. The wall of fire is the glowing prow of our ship, the region where the friction of our passage is made manifest. To understand this structure is to understand the nature of our own motion through the cosmos. It gives us a tangible sense of our place not as a fixed point, but as a dynamic entity, forever sailing through the star-dusted currents of the Milky Way, our path marked by this invisible, superheated wake. The cosmic rays that are born in distant supernovae are the universe's great messengers. They travel for millions of years, their paths bent by galactic magnetic fields, before arriving at our solar system. The heliosphere, our wall of fire, acts as a giant spectrometer, filtering them by energy. By comparing the cosmic ray flux measured by Voyager outside the heliopause to what we see near Earth, we can precisely quantify the shielding effect of our home. This allows us to understand not only our own defense system, but also to better interpret the cosmic ray signals that bombard our planet, separating the local from the galactic and piecing together a more accurate picture of the high-energy universe. The very atoms that make up our bodies were once part of the interstellar medium. Billions of years ago, the cloud of gas and dust that would become our solar system was just another piece of the galactic environment. It was from this raw material, this interstellar sea, that our sun and planets condensed. In studying the local interstellar cloud today, we are, in a sense, studying our own primordial ancestry. The particles that Voyager 1 is now touching are the cousins of the particles that built our world. This knowledge creates a deep and visceral connection to the cosmos, reminding us that we are not separate from it, but are truly and literally made of stardust. Let us contemplate the immense patience of this kind of science. The Voyager probes were launched before many of their current mission scientists were even born. The data they collect is the result of decades of careful planning, navigation, and engineering. An entire generation of researchers has passed the torch to the next, building a cumulative understanding over a timescale that transcends individual careers. This long, slow, and meticulous process of discovery is a powerful counterpoint to the fast pace of modern life. It speaks to a deeper human drive to understand our origins, a quest so profound that we are willing to invest our entire lives in adding just one more small piece to the magnificent puzzle. The wall of fire is a feature not just of our sun, but likely of most stars. This means the galaxy is filled with trillions of these astrospheres, each one a bubble of stellar influence pushing back against the interstellar medium. From a great distance, the galaxy would look like a frothy, bubbly structure, a cosmic foam of interacting stellar winds. Each bubble is a potential sanctuary, a shielded region where planets might be protected enough for life to evolve. Our understanding of our own heliosphere is therefore the key to understanding the galactic habitable zone not just as a region of space, but as a dynamic ecosystem of protected stellar harbors scattered throughout the vastness of the Milky Way. The concept of the heliopause as a magnetic boundary is crucial. Charged particles, like cosmic rays or solar wind protons, find it very difficult to cross magnetic field lines. They are forced to spiral around them. The heliopause is essentially where the well-organized magnetic field of our sun gives way to the ambient magnetic field of the galaxy. For a charged particle, this is a fundamental change in the rules of the road. It marks a transition from a local, radial magnetic highway system to a vast, complex, and seemingly chaotic galactic network. This is why the crossing of the heliopause is marked by such a sharp and definitive change in the particle environment, a true iron curtain for charged particles. The energy in the solar wind is not insignificant. The total power it carries as it flows past the Earth is thousands of times greater than all the power consumed by humanity. This energy is spread over a vast area, but it is a constant and powerful outflow. When this immense kinetic energy is finally dissipated at the termination shock and in the heliosheath, it is converted into the thermal energy that constitutes the wall of fire. It is a beautiful example of the conservation of energy on a system-wide scale. The energy of motion that dominates the inner solar system is transformed into the energy of heat at its outer boundary, a final diffuse glow powered by the relentless heart of our star. The discovery of the heliosphere's true nature has had a ripple effect through many areas of science. For planetary scientists, it provides the outer boundary conditions for their atmospheric models. For astrobiologists, it defines a crucial component of planetary habitability. For plasma physicists, it is a natural laboratory of unparalleled scale. For astronomers, it is the foreground filter through which they view the rest of the universe. The wall of fire is not an isolated curiosity. It is a nexus of disciplines, a place where multiple threads of scientific inquiry converge. Its study enriches our understanding not just of space, but of the fundamental interconnectedness of all physical science. Let's reconsider the ibex ribbon. One intriguing theory for its existence involves a process of spatial retention. Imagine the interstellar magnetic field lines draping over our heliosphere. As energetic neutral atoms are created at the boundary, the ones whose paths happen to align perfectly with our line of sight to these draped magnetic field lines are the ones we see most brightly. The ribbon, in this view, is a geometric effect, a place where we are looking directly down the barrel of the magnetic field, seeing an integrated, amplified signal. If this is true, the ribbon is a compass, showing us the precise direction of the galactic magnetic field in our local neighborhood, a stunning piece of cosmic cartography. The profound emptiness of the space the Voyagers now travel through is a defining characteristic of their new environment. In the solar wind near Earth, there are about 5 to 10 particles per cc. In the interstellar medium just beyond the heliopause, that number is only about 0.1 particle per cc. While this is actually denser than the highly rarefied plasma of the outer heliosheath, the nature of the particles is completely different. The profound vacuum of interstellar space is filled with a cold, slow-moving plasma and a relentless, high-energy rain of cosmic rays, a far cry from the hot, fast, and relatively uniform solar wind that defines our home. This knowledge invites a form of cosmic empathy. We can look at a star in the night sky and now understand that it too is likely surrounded by its own protective bubble, its own fiery boundary. It too is a vessel journeying through the galaxy, contending with the interstellar winds. We can imagine potential worlds orbiting that star, shielded by the same physical processes that shield our own. This shared cosmic architecture connects us to every star in the sky. It transforms them from distant, abstract points into kindred systems, each with its own story, its own boundary, and its own place within the grand, interconnected ecosystem of the Milky Way. The magnetic field our Sun generates is incredibly complex. It is not a simple bar magnet. Because the Sun rotates differentially, faster at its equator than at its poles, the field lines become twisted and sheared, leading to the buildup of immense magnetic energy. This energy is then released in the form of solar flares and coronal mass ejections. These events are the source of the weather within the heliosphere. A massive solar storm is like a hurricane propagating through the solar system, and the termination shock and heliosheath are the distant shores upon which this storm finally breaks, its energy dissipating and contributing to the heat of the wall of fire. The very idea that we can know these things is a source of profound wonder. We are a species confined to the surface of a single, small planet, yet through the power of reason, mathematics, and engineering, we have extended our senses across billions of miles. We have touched the interstellar medium. We have measured the temperature of a plasma wall so distant that its light would take nearly a day to reach us. This achievement is a testament to the relentless curiosity that is the noblest aspect of our nature. It is a reminder that there are no fundamental limits to our understanding, only temporary limits to our technology and our imagination. One of the most subtle influences of the heliosphere is on the trajectory of comets. The Oort cloud, a vast, spherical reservoir of trillions of icy bodies, is thought to exist at the far outer edges of our solar system, possibly extending out into the heliosheath. The gravitational tides of the Milky Way galaxy itself can perturb these comets, sending them on long journeys toward the inner solar system. However, their paths may also be influenced by the pressure and structure of the heliosheath and the interstellar medium. Understanding our boundary is therefore part of understanding the origin and delivery mechanism of the very comets that may have brought water and organic molecules to the early Earth. The Wall of Fire is a monument to the unseen. Our universe is dominated by forces and substances that are invisible to us: dark matter, dark energy, magnetic fields, and tenuous plasmas. The heliosphere is our most intimate and accessible example of this invisible architecture. Its study is a training ground for our scientific minds, teaching us how to infer the structure of the unseen from its subtle effects on the seen. By charting our own magnetic bubble, we develop the tools and the intuition needed to tackle the even greater mysteries of the invisible universe, to map the dark scaffolding upon which the luminous galaxies are built. As we move through the galaxy, we will eventually leave the local bubble and enter a new region of interstellar space, one that may be much denser. When this happens, our heliosphere will shrink dramatically. The ball of fire could be pushed inwards, closer to the outer planets. This would have a profound effect on our solar system. The increased influx of cosmic rays and interstellar gas could alter the chemistry of planetary atmospheres and potentially pose a risk to life on Earth. The long-term safety of our biosphere is therefore tied to the galactic forecast, a slow-motion drama playing out over millions of years, with our heliosphere as our first and most important line of defense. The data from the Voyager probes is a gift to the future. It is being meticulously archived and made public so that future generations of scientists, armed with more advanced analytical tools and a more complete theoretical understanding, can re-examine it and uncover new insights. The journey of Voyager does not end when its transmitter falls silent. Its legacy will continue for as long as there are curious minds to study the priceless data it has bequeathed to us. It is a scientific time capsule, a snapshot of the edge of our solar system from the late 20th and early 21st centuries, preserved for the ages. The boundary of our solar system is not a desolate wasteland, but a region of intense energy conversion. Kinetic energy from the solar wind is transformed into thermal energy in the plasma. This thermal energy is then radiated away, albeit very inefficiently. Furthermore, magnetic energy is released during reconnection events. The heliosheath is a giant, slow-motion engine, constantly processing energy and mediating the flow between our Sun and the galaxy. To understand this energy budget is to understand the fundamental metabolism of our solar system, the way it consumes the output of its star and interacts with its galactic environment. The discovery that the heliosphere may not be comet-shaped, but rather more spherical or even split into lobes, has profound implications. A long tail would have acted as a conduit, a protected channel shielded from the interstellar medium. A more bubble-like shape suggests a more uniform interaction with the galaxy in all directions behind us. It changes our understanding of how interstellar material might filter into our solar system from the wake of our passage. The true shape of our home is one of the most pressing questions in heliophysics, and its answer will rewrite the textbooks on our relationship with the galaxy. Let us contemplate the nature of a shockwave in this context. It is not a wall of air, but a discontinuity in the magnetic field and the flow of plasma. On one side of the termination shock, information can flow upstream against the supersonic solar wind. On the other side, it cannot. The shock is a one-way information barrier for certain types of plasma waves. It is a place where the rules of cause and effect are subtly altered by the physics of fluid dynamics. This abstract, beautiful concept is made real at the edge of our solar system, a place where the very fabric of the solar wind is fundamentally and irrevocably changed. The heliosphere is the largest physical structure that humanity can truly lay claim to. It is the bubble of influence of our star, and by extension, our home system. Its sheer scale is an antidote to anthropocentrism. To contemplate a structure so vast that it takes our fastest probes decades to cross is to be humbled. It places our terrestrial concerns in a cosmic perspective. It reminds us that we are part of a system of magnificent and serene grandeur, a system that operates on scales of time and space that are almost beyond our ability to grasp, yet not beyond our ability to understand. The wall of fire can be seen as the final exhalation of the sun. The journey begins in the core, with a photon taking 1,000,000 years to reach the surface. It continues as that energy drives the solar wind, which flows for years to the outer system. The final act of this long journey is the dissipation of that wind's energy into heat at the boundary. It is the end of the line for the material ejected from our star. From here, it will slowly mix with the interstellar medium and lose its identity, its last act, a faint, hot glow that defines the sphere of its influence. It is a beautiful and complete life cycle, from stellar core to interstellar ghost. We are still in the infancy of interstellar exploration. The Voyager probes are like the first primitive rafts pushed out into a vast ocean. They have shown us that the sea is navigable, but they have also revealed the presence of unexpected currents, strange weather, and a complex shoreline. The future lies in building true ships, like a dedicated interstellar probe, that can sail this ocean with purpose. The discovery of the wall of fire and the complex heliosheath is not an endpoint, but an invitation. It is the universe challenging us to come and explore, to build better instruments, to ask deeper questions, and to continue our species' sacred and unending journey of discovery. The silence of the Voyager probes, when they eventually fall, will not be an ending. The knowledge they have given us will continue to resonate through the halls of science for centuries. Their legacy is not in their continued transmission, but in the fundamental shift in perspective they have given us. They have allowed us to see our solar system from the outside in, to understand it not as an isolated island, but as an integral, interacting part of the galactic ecosystem. They have drawn the map of our home, and on its distant shores they have written, "Here, there be wonders." The plasma within the wall of fire exists in a state of non-equilibrium. The electrons, protons, and heavier ions, do not all share the same temperature. Different particle species are heated by different amounts and through different mechanisms at the termination shock. This complex thermal state is a rich field of study. It challenges our simple models and forces us to develop a more nuanced understanding of how energy is distributed in a collisionless plasma. The heliosheath is a laboratory for thermodynamics in its most exotic form, a place where our terrestrial notions of temperature break down into a more complex and fascinating reality. It is a remarkable fact that the pressure exerted by galactic cosmic rays is a significant component of the total pressure of the interstellar medium. These few, high-energy particles, traveling at near light speed, collectively exert a pressure that helps to hold back our solar wind and shape our heliosphere. This is a universe where the most energetic and the most tenuous phenomena can have a profound structural influence. The wall of fire exists in part because of the relentless pressure exerted by particles born in supernovae thousands of light years away and millions of years ago. It is a testament to the long-range and long-lasting influence of the galaxy's most violent events. The study of the heliosphere's boundary is ultimately a study of boundaries in general. In nature, boundaries are rarely simple lines. They are almost always complex, dynamic interfaces where energy and matter are exchanged. Think of a coastline, a cell membrane, or the boundary between tectonic plates. The heliopause and its associated structures are the grandest example of such an interface we can study. By understanding its physics, we learn universal lessons about how systems interact, how they maintain their identity, while still being connected to their environment, a principle that echoes from the cosmic down to the biological scale. The ultraviolet glow from the hydrogen wall has been detected by telescopes, providing a way to see this structure remotely. As sunlight from our own star scatters off the piled-up neutral hydrogen atoms at the frontier, it creates a faint, diffuse ultraviolet light. By mapping this light, we can get a global picture of the wall's shape and density, complementing the direct, pinprick measurements from the Voyager probes. It is like seeing the faint glow of the surf on a distant, dark shore. This technique allows us to take a step back and see the grand architecture of our home's interaction with the galaxy, a beautiful confluence of theory and observation. The existence of the heliosphere has a subtle but profound effect on our view of the cosmos. Because it filters out the low-energy fog of the interstellar plasma and some of the cosmic ray background, it provides a clearer, more stable environment for life and for astronomy within it. In a sense, our bubble is a zone of exceptional cosmic clarity. It is another Goldilocks condition. We are in a region of space that is not only protected from the harshest radiation, but is also uniquely suited for looking out upon the universe and comprehending its wonders. The wall of fire is the boundary of our cosmic observatory. What lies in the future for our heliosphere? In a few tens of thousands of years, our journey will take us out of the local interstellar cloud and into a neighboring wisp of gas with different properties. The heliosphere will react and reconfigure itself. The wall of fire will change its temperature and shape. The long-term story of our solar system is one of constant adaptation to a changing galactic climate. By understanding the physics of our current boundary, we are equipping ourselves to predict the future of our cosmic shield, to foresee the changes that will greet humanity in the unimaginably distant future as our silent journey through the Milky Way continues. Let us appreciate the human ingenuity that made this discovery possible. The engineers who designed spacecraft to last for half a century. The navigators who could aim a probe across billions of miles of empty space to a precise location. The scientists who could interpret the faint whispers of data to reconstruct a magnificent, invisible structure. The story of the Wall of Fire is as much a human story as it is a cosmic one. It is a story of our species at its very best, curious, patient, collaborative, and capable of achieving the seemingly impossible through the disciplined application of science and reason. Every time a solar flare erupts from the sun, a pressure wave is sent rippling through the solar system. This wave travels for months, eventually striking the termination shock and the heliopause. The entire heliosphere reverberates like a giant bell struck by a hammer. The Voyager probes have been able to detect these reverberations, these, quote, heliospheric tsunamis, as they pass by. This shows that the boundary is not a rigid wall, but a flexible, elastic surface that is constantly responding to the turmoil at its center. Our cosmic shield is not a static fortress, but a living, breathing membrane that flexes and adapts to protect its inhabitants. The journey beyond the Wall of Fire has just begun. As the Voyager probes drift deeper into the interstellar sea, they continue to reveal its secrets. They have detected the shockwaves from our own sun propagating out into the galactic medium, a discovery that was completely unexpected. They are painting a picture of a complex and dynamic environment, where the influence of a single star can be felt long after its physical boundary has been crossed. We are learning that the separation between our home and the galaxy is not as clean and simple as we once thought, but is a messy, beautiful, and ongoing conversation. The awe inspired by the Wall of Fire is an intellectual awe. It is the feeling that arises when a complex and seemingly paradoxical phenomenon is made clear through elegant physical principles. It is the joy of understanding, of seeing how the universe works on a grand scale. This is a deeper and more lasting form of wonder than mere spectacle. It is a state of contemplative calm that comes from appreciating the intricate order and hidden beauty that lies beneath the surface of reality. It is the reward for our patient and persistent quest to understand our place in the cosmos. The magnetic field lines in the interstellar medium are thought to be connected to the grand magnetic field of the galaxy as a whole. As Voyager 2 continues its journey, it is slowly tracing a path along these galactic lines of force. It is, in a very real sense, mapping the magnetic skeleton of our local corner of the Milky Way. This data is invaluable. It helps us understand how the galaxy is structured, how it rotates, and how it confines the cosmic rays that permeate its volume. Our tiny probes, having left our home, are now becoming instruments for galactic science on the grandest possible scale. Let's consider the heliosphere's role in the context of time. Life on Earth has existed for roughly 4 billion years. During that entire period, the heliosphere has been our constant, unwavering guardian. It has silently deflected countless cosmic rays, stabilized our cosmic climate, and provided the protected niche necessary for the slow, patient process of evolution to unfold. We owe our very existence not just to the light of our sun, but to its breath, the solar wind, and the magnificent fiery shield it builds at the edge of our world. It is the unsung hero of our planet's story, the silent sentinel that has watched over us since the very beginning. The interstellar medium is not empty, but it is also not uniform. It is structured into a complex web of clouds, filaments, and voids, sculpted by supernova explosions and stellar winds. The Voyager probes are now giving us our first direct sample of this, quote, interstellar weather. They have found that the plasma density can change dramatically over relatively short distances, indicating that we are passing through fine, thread-like structures in the local cloud. We are beginning to map the very texture of the space between the stars, a texture that was, until now, completely inaccessible to us. The discovery of the Wall of Fire is a powerful reminder that our models of the universe are always incomplete. Before the Voyager crossings, our theories of the heliosphere's edge were much simpler. The reality, as is so often the case, turned out to be far richer, more complex, and more interesting than our imagination had allowed. This is the beauty of exploration. It forces us to confront the universe on its own terms, to discard our simplified pictures and to embrace the messy, intricate, and ultimately more profound truth. Every journey to a new frontier is a lesson in humility and a catalyst for a deeper understanding. The energy density of the magnetic field in interstellar space is comparable to the energy density of the plasma and the starlight itself. This means that magnetism is not a minor player. It is one of the dominant forces shaping the galaxy. It is the invisible scaffolding that governs the structure of the interstellar medium and mediates the interaction between stars. The heliosphere's boundary, where our field meets the galactic field, is therefore a place of profound physical importance. It is a microcosm of the fundamental struggle between stellar and galactic magnetism that plays out across the entire Milky Way, a silent, powerful, and deeply fundamental process. To contemplate the Wall of Fire is to connect with a timeless cycle. The particles in the solar wind were once part of the sun. They are ejected, travel to the boundary, and then mix with the interstellar medium. This medium, enriched by countless other stars, will one day collapse to form a new star and new planets. The atoms that once made up our solar wind could, in the distant future, become part of a new world, perhaps one that harbors life. Our sun is constantly contributing its essence back to the galaxy, participating in the endless cycle of stellar birth, death, and rebirth. The heliosphere is the membrane through which this sacred exchange takes place. The future of this science will involve not just sending probes out, but also looking at our heliosphere from the outside in. Imagine a future telescope, perhaps positioned hundreds of astronomical units away, looking back at our solar system. It could directly image the ultraviolet glow of the hydrogen wall, and perhaps even detect the radio emissions from the turbulent plasma. Such an observation would provide a truly global perspective, allowing us to see our home as other star systems must see it. A tiny, glowing bubble of life and activity, sailing serenely through the vast and silent darkness of the galaxy. The existence of the Wall of Fire provides a sense of cosmic closure. It gives our solar system a definitive, physical boundary. It is the final, grandest feature of our home. From the fiery surface of the sun, through the orbits of the planets, past the asteroid and Kuiper belts, the system finally culminates in this vast, hot, and turbulent shield. It is a fittingly dramatic and complex end to the sun's dominion. Knowing that our system does not just fade into nothingness, but terminates in this magnificent structure, provides a sense of completeness to our celestial map, a final, satisfying chapter in the story of our place in the universe. This entire exploration is a monument to the power of a single, simple question. What happens if we keep going? It is the question that has driven every explorer in human history, from the first to cross an ocean to the first to step on the moon. The Voyager mission is the ultimate expression of this impulse. By simply continuing to travel, by refusing to stop at the known planets, we have uncovered a new and unexpected layer of reality. It is a powerful lesson that the greatest discoveries are often made not by looking for something specific, but by simply pushing into the unknown, with open eyes and a mind ready to be astonished. In the quiet contemplation of this distant frontier, we find a profound sense of peace. The universe, in its immense scale and complexity, operates on principles of serene and immutable physical law. The Wall of Fire is not a chaotic accident, but a stable, predictable, and beautiful consequence of those laws. Its existence is a testament to the underlying order of the cosmos. To understand this is to feel a sense of belonging, a sense that we are part of a rational and comprehensible universe. It is a deep, intellectual tranquility, a calm that comes from seeing our own small existence reflected in the grand, silent, and elegant mechanics of the heavens. The heliosphere, in its entirety, can be conceptualized as a single, vast organ of the Milky Way galaxy. It is not separate from the galactic body, but a functional component within it. Like a cell in a larger organism, it has a membrane, the heliopause, that mediates the exchange of energy and matter with its surroundings. It processes material from the sun and exhales it into the interstellar medium, while simultaneously filtering the galactic environment to create a stable internal state. This biological metaphor helps us to appreciate the deep, functional interconnectedness of the cosmos. Our solar system is not a machine of independent parts, but a living, breathing entity, fully integrated into the life of the galaxy. The materials that constitute the interstellar medium are on a grand journey of their own, a galactic fountain of cosmic recycling. Gas is pulled from the galaxy's halo, cools and condenses into dense molecular clouds in the spiral arms, and then collapses to form new generations of stars. These stars, through their stellar winds and final supernova explosions, eject processed material back into the medium. Our heliosphere is currently passing through this recycled gas. The Wall of Fire is the precise location where our sun's own recycled material meets the collective recycled material of countless other stars. It is a boundary between our local history and the grand, sweeping history of the entire galactic disk. The sounds of space, as captured by the plasma wave instruments on the Voyager probes, offer a unique sensory dimension to this distant frontier. These are not sounds in the conventional sense, but radio emissions from the plasma, converted into audible frequencies. As Voyager 1 crossed the heliopause, the sound of the plasma changed dramatically. The steady, low hiss of the heliosheath was replaced by a higher-pitched, more variable tone, the signature of the denser interstellar medium. It was as if the probe had sailed out of a quiet river and into a murmuring ocean. These recordings are the soundtrack to humanity's first interstellar journey, a haunting and beautiful melody played by the physics of the void. The Wall of Fire is a powerful lesson in the nature of scientific truth. For decades, our models of this region were based on elegant but incomplete theories. The direct measurements from the Voyager probes forced a revision of these models, revealing a reality far more complex and fascinating. This is the hallmark of scientific progress, a constant dialogue between theory and observation, where nature always has the final say. The universe is the ultimate arbiter of truth. Our task is not to impose our ideas upon it, but to listen humbly to the data it provides, and to be willing to discard our most cherished theories when the evidence demands it. Let us contemplate the future fate of the heliosphere. In about 5 billion years, our sun will exhaust the hydrogen fuel in its core and begin to evolve into a red giant. Its outer layers will swell enormously, engulfing the inner planets. The solar wind it produces will become slow, massive, and dense. This will dramatically alter the heliosphere, likely inflating it to a colossal size, creating a far larger but cooler boundary. Eventually, the sun will shed its outer layers to form a planetary nebula, and the solar wind will cease entirely. The heliosphere, our protector for billions of years, will finally dissipate, its material returning to the interstellar medium from which it came, its long watch finally over. The discovery of this complex boundary serves as a cautionary tale for our search for extraterrestrial life. When we observe exoplanets, we are seeing them through the filter of their own astrospheres. The light from an alien world is subtly altered as it passes through this boundary, and our own view is filtered by our heliosphere. Furthermore, the habitability of a planet is critically dependent on the shielding its star provides. We cannot simply look at a planet, we must understand its entire stellar system in context. The Wall of Fire teaches us that a planet's environment does not end at its atmosphere, but extends to the farthest reach of its star's breadth. The emotional impact of this discovery is one of profound duality. It inspires a sense of immense isolation, highlighting the vast, empty gulfs that separate the stars. Yet, it also fosters a feeling of intimate connection, revealing the physical processes that bind us to the galactic ecosystem. We are simultaneously alone and deeply interconnected. To hold these two seemingly contradictory ideas in the mind at once is to touch upon a fundamental truth of the human condition in a cosmic context. We are solitary voyagers on a lonely vessel, yet our vessel is made of the same substance as the sea, and we are forever part of the grander cosmic ocean. The future of exploration in this realm may not be physical probes alone, but also advanced remote sensing. A sufficiently powerful radio telescope could potentially detect the faint radiosynchrotron emission from energetic electrons spiraling in the magnetic fields of the heliosheath. This would allow us to image our fiery boundary from Earth, to see its shape and structure in real time. This would complement the in-situ data from probes, much as satellite weather maps complement ground-based weather stations. The quest to fully visualize our home in the galaxy is a grand challenge that will drive technological innovation for decades to come, bringing this distant, invisible wall into focus. The Wall of Fire is a testament to the power of a star. Every aspect of this magnificent structure is a direct consequence of the nuclear furnace burning 10 billion miles away at its center. The sun's gravity holds the system together, but it is the sun's light and wind that give it life, character, and defense. The heliosphere is the ultimate expression of our star's vitality, a projection of its power into the galaxy. To understand the wall is to appreciate the full extent of the sun's influence, an influence that not only warms our planet and drives our biology, but also builds a celestial fortress to keep us safe on our long journey. As we look out at the Milky Way stretching across the night sky, we are looking at a cross-section of the very medium our heliosphere is traveling through. The dark dust lanes are the denser clouds our bubble must navigate around or push through. The bright, starry regions are the source of the cosmic rays our shield must deflect. With the knowledge of the heliosphere, the view of our galaxy is transformed. It is no longer a static, painted backdrop. It is the weather, the environment, the physical sea that is actively interacting with our vessel at this very moment, its currents and storms breaking against the fiery, invisible bow of our solar system. This entire saga of discovery evokes a feeling of deep, quiet pride in what humanity can accomplish. We are a young species beset by conflicts and short-sightedness, yet we are also capable of this, of building machines that can outlast their makers, of asking questions that span generations, and of patiently listening for answers from the very edge of our world. The story of Voyager and the Wall of Fire is a powerful antidote to cynicism. It is a reminder of our potential, a testament to what we can achieve when we are motivated by the pure, noble, and unifying desire to simply understand. The knowledge of this boundary reshapes our sense of place. For millennia, humanity has defined its home in ever-expanding circles: the valley, the continent, the planet, the system of planets. The discovery of the heliosphere provides the next, and perhaps final, circle in this sequence. Our home is this bubble. Everything inside it is, in a sense, local. Everything outside is galactic. This provides a new, physically meaningful definition of our cosmic address. It is a boundary that is not based on culture or politics, but on the fundamental physics of our star. It is a unifying concept for all of humanity, the shared shoreline of our collective world. The Wall of Fire exists at the boundary between the predictable and the chaotic. Inside, the solar wind creates a relatively orderly, if turbulent, environment dominated by a single source. Outside lies the far more complex and unpredictable galactic medium, shaped by the combined influence of billions of stars and countless supernova explosions. The heliosheath is the transition zone, a chaotic buffer where these two regimes meet. To study it is to study the nature of complexity itself, to see how order gives way to chaos, and how a stable system can maintain its integrity even when faced with an infinitely complex and unpredictable external environment. Let us contemplate the sheer elegance of the solution. The universe needed a way to mediate the interaction between a star's outflow and the galactic medium. The solution it found, through the simple laws of plasma physics, is this multi-layered system of shocks and sheaths. It is a self-organizing, self-regulating structure that is both robust and flexible. There is a deep architectural beauty to it, a sense of rightness and inevitability. The Wall of Fire is not a strange anomaly. It is the perfect physical answer to a fundamental cosmic question. Its discovery is like finding a hidden line of poetry in the grand mathematical verse of the universe. The journey of the Voyager probes through this region is a powerful narrative of perseverance. For years, they sailed through the relatively calm seas of the outer solar system, and then they entered the storm of the heliosheath. They were battered by turbulence and anomalous cosmic rays, their sensors reporting a chaotic and confusing environment. Yet, they endured. They pushed through the tempest and emerged into the serene calm of the interstellar medium. It is a story that resonates with our own human experience. The necessity of navigating through periods of chaos and uncertainty to reach a new and deeper understanding, a place of newfound clarity and peace. The next great leap in understanding this frontier will require a new kind of mission, one that can not only travel through the boundary, but can also linger there. Imagine a probe that could enter into an orbit around the termination shock itself, or one that could release a series of small sub-probes to measure the properties of the heliosheath in multiple locations simultaneously. This would give us a true weather map of this distant region, allowing us to watch storms and turbulence evolve in real time. This is the future of heliophysics, to move beyond single-point flybys and establish a permanent, sentient presence at the final frontier of our home. The Wall of Fire is a profoundly democratic discovery. The data from the Voyager mission is publicly available, accessible to any person on Earth with an internet connection. Anyone, from a professional astrophysicist to a curious high school student, can download the raw telemetry and see for themselves the evidence for this incredible structure. This openness is a cornerstone of the scientific endeavor. It ensures that this knowledge does not belong to a select few, but is the common heritage of all humanity. It is a gift from the cosmos, delivered by our robotic emissaries and offered freely to every mind that wishes to receive it. This discovery places our sun in a community of stars. By understanding how our star creates its astrosphere, we can better understand the spheres of other stars we observe. We can see the bow shocks of runaway stars like Zeta Ophiuchi and know that we are seeing a far more powerful and dramatic version of the same physics that shapes our own home. It allows us to connect our personal, intimate experience of our sun to the grand dynamic lives of stars throughout the galaxy. Our star is not a solitary actor, but a member of a vast stellar society, and the Wall of Fire is the personal space it maintains within that cosmic crowd. The final legacy of the Voyager probes will be one of inspiration. They are a tangible symbol of what can be achieved when we aim high and dare to explore. For generations to come, they will serve as a benchmark for human ambition. They are the yardstick against which future missions of exploration will be measured. Their journey through the Wall of Fire and into the unknown is a story that will be told and retold, a modern epic of science and engineering that will continue to inspire young minds to look up at the stars and ask that most powerful of questions: what lies beyond? Contemplating the heliosphere's vast, silent, and fiery boundary is a form of meditation. It requires us to quiet our minds and expand our sense of scale. We must let go of our terrestrial biases and embrace a universe of immense voids, invisible forces, and paradoxical phenomena. In this state of expanded awareness, a sense of profound peace can emerge. It is the peace of perspective, the calm that comes from understanding our own smallness in the face of cosmic grandeur, and yet also our profound significance as the universe's means of knowing itself. The Wall of Fire is a cosmic mandala, a focus for contemplating our place in the all. The upcoming Interstellar Mapping and Acceleration Probe, or IMAP, represents the next chapter in this story. Launching in the near future, it will be a dedicated observatory for the heliosphere's boundary, but observed from near Earth. With instruments far more sensitive than those on IBEX, it will create a high-resolution map of the entire celestial sphere in energetic neutral atoms. It will give us a detailed, dynamic view of the Wall of Fire, the IBEX ribbon, and the flow of interstellar material around our home. IMAP will not travel to the boundary, but it will give us the sharpest eyes we have ever had to watch it from afar, transforming our blurry snapshot into a high-definition film. One of the most compelling mysteries that future missions will need to solve is the heliospheric filtration problem. We know that neutral interstellar atoms are filtered as they cross the boundary, but the precise efficiency of this filter is unknown. This is crucial because it determines the chemical composition of the material that rains down on our outer solar system. A future probe that can simultaneously measure the composition of the interstellar medium outside and the neutral gas inside will finally allow us to quantify this process. It will be like measuring the precise mesh of the sieve that separates our home from the galaxy, a crucial parameter for understanding our local cosmic ecology. Another key goal for the future is to understand the acceleration of particles at the termination shock. While we know this happens, the exact physical mechanisms are still debated. The termination shock is a collisionless shock, meaning particles interact via electromagnetic fields, not direct collisions. Understanding how these fields can efficiently transfer energy and accelerate particles to near-light speeds is a fundamental problem in plasma astrophysics. A future probe with high-speed instruments could fly directly through the shock and measure these fields and particles in action, providing a definitive answer to a mystery that has implications for everything from solar flares to supernova remnants. The ultimate dream for many in this field is a true interstellar mission that can travel not just beyond our heliosphere, but can reach the nearest stars. This would require revolutionary new propulsion technologies, such as solar sails pushed by powerful lasers or fusion-based rockets. While such a mission is likely centuries away, it is the logical endpoint of the journey that Voyager began. The Wall of Fire is the first step on that path. By learning to navigate our own shoreline, we are taking the first tentative steps needed to one day build the ships that will allow humanity to finally sail the great ocean between the stars and visit other suns. In the nearer term, scientists are exploring the possibility of using the sun's own gravity as a lens to see distant objects. A spacecraft positioned at the solar gravitational focus, about 550 times the Earth's sun distance, could use the sun to magnify the light from an exoplanet, potentially allowing us to see its surface in detail. Such a mission would have to travel deep into the heliosheath, right up to the doorstep of the Wall of Fire. The exploration of our own outer boundary is therefore inextricably linked with our quest to see other worlds. To see the small and distant, we must first journey through the large and near. As our technology improves, we may one day be able to study the astrospheres of other stars in the same detail that we now study our own. By analyzing the faint ultraviolet and radio signals from their boundaries, we could map their shapes, infer the strength of their stellar winds, and perhaps even detect the chemical composition of their local interstellar medium. We would be able to perform comparative heliophysics, studying the diversity of stellar bubbles across the galaxy. This would transform our understanding from a single, specific case, our own, to a general universal theory of how stars and galaxies coexist and co-evolve. The philosophical implications of the wall of fire are profound. It is a physical manifestation of the idea that all systems are defined by their boundaries. An organism is defined by its skin, a culture by its language, a planet by its atmosphere. Our solar system is defined by its heliosphere. This boundary is what gives it its identity, its coherence, and its stability. It teaches us that to exist is to be bounded, to be distinct from one's environment, while also being in constant exchange with it. It is a deep and universal principle, written in fire and plasma across a canvas a billion miles wide. The beauty of this discovery is that it does not provide all the answers. Instead, for every question it answers, it opens up a dozen new ones. We have solved the mystery of what lies at the edge of the sun's influence, only to be confronted with the new mysteries of the ibex ribbon, the shape of the heliotail, and the precise physics of collisionless shocks. This is the true nature of science. It is not a process of finding final answers, but a process of finding better and more interesting questions. The Wall of Fire is not an end to the story, but the beginning of a new and far more exciting chapter. To fully appreciate this phenomenon is to engage in an act of profound imagination. We must imagine a journey of decades across a silent void. We must visualize a wall that is hotter than a star's surface, yet colder than the deepest freeze. We must comprehend a shockwave that makes no sound. To engage with this reality is to stretch our minds, to build new neural pathways capable of holding these cosmic scale concepts. Science is not just a collection of facts, it is a training for the imagination. And the Wall of Fire is one of its most challenging and rewarding exercises. The Wall of Fire is a source of cosmic optimism. It is a demonstration that even in the vast, cold emptiness of space, protective niches can form. It shows that a single star has the power to create a local environment that is shielded, stable, and conducive to the emergence of complexity. It suggests that the universe is not inherently hostile to life, but is rather a place of potential harbors and sanctuaries. As we search for life elsewhere, the existence of our own fiery shield gives us a rational basis for hope, a reason to believe that other worlds may also be resting safely within the protective cocoons of their own parent stars. The boundary of the heliosphere can be seen as a metaphor for consciousness. Our minds create a bubble of reality, a coherent world of thoughts, perceptions, and memories, based on the sensory data flowing in from the external world. This internal world is separated from the raw, unfiltered chaos of external reality by a semi-permeable boundary of perception and interpretation. The Wall of Fire is like this boundary, a place of intense activity and transformation, where the external is processed and filtered to maintain the stable, internal environment necessary for thought and identity to exist. We each travel through the world encased in our own personal heliosphere. The silence of interstellar space, just beyond the wall, is a silence pregnant with meaning. It is the quiet canvas upon which the faint whispers of the cosmos can finally be heard, without the overwhelming noise of our own sun. In this silence, Voyager can hear the hum of the galactic plasma and the distant rumble of cosmic rays. This teaches us a valuable lesson, that true listening, true perception, often requires us to first move beyond the noise of our own immediate environment, to cross a boundary into a place of stillness, where the more subtle and profound signals of reality can finally be perceived. The Wall of Fire is a perfect example of a liminal space. It is a threshold, a place that is neither fully inside our solar system nor fully outside in the galaxy. It is the in-between. Such spaces are often places of transformation and great power in human mythology and psychology. To pass through them is to be changed. The Voyager probes were changed when they crossed this boundary, graduating from planetary to interstellar explorers. This cosmic threshold reminds us of the importance of such passages in our own lives, the moments of transition that define our journey and move us from one state of being to another. This discovery reinforces the humbling truth that we are not the center of the universe. Our entire solar system, including its magnificent fiery boundary, is being shaped and sculpted by external forces, by the interstellar wind and the galactic magnetic field. We are not a kingdom, but a province. Our home is subject to the laws and the weather of a much larger entity. This knowledge erodes our cosmic arrogance and replaces it with a sense of participation in a grander system. We are a part of the Milky Way, not just observers of it, and our very structure is a testament to that deep and unbreakable connection. The long, patient journey of the Voyager probes is a lesson in delayed gratification. In a world that often demands instant results, this is a story that has unfolded over half a century. The scientists who conceived of the mission knew they might not live to see its ultimate discoveries. They planted a seed, nurtured it, and trusted that future generations would be there to harvest its fruit. This long-term perspective is essential for any great undertaking. The Wall of Fire was not discovered in a flash of genius, but was revealed through the steady, patient, and hopeful work of generations. The paradox of a hot wall that transfers no heat is a Zen-like koan from the universe. It challenges our intuitive understanding and forces us to a deeper, more abstract level of comprehension. It demonstrates that our earthbound language is often inadequate to describe cosmic reality. Words like hot and wall are metaphors, useful pointers towards a truth that can only be fully grasped through the language of mathematics and physics. To contemplate this paradox is to exercise our mental flexibility, to learn to see the world not just as it appears to our senses, but as it truly is according to the fundamental laws of nature. The heliosphere provides a sense of cosmic identity. When we ask the question, "Where are we?" the answer is no longer simply "on Earth." A more complete answer is, we are within the heliosphere, a bubble of solar plasma currently moving through the local interstellar cloud, inside the local bubble, within the Orion arm of the Milky Way galaxy. Each new discovery adds another line to our cosmic address, giving us a more precise and profound sense of our location in the grand scheme. The Wall of Fire is the outermost fence of our celestial property, the line that separates our yard from the vast wilderness of the galaxy. Ultimately, the Wall of Fire inspires a feeling of profound gratitude. Gratitude for the star that provides not only warmth and light, but also this incredible, invisible shield. Gratitude for the laws of physics that allow such elegant and protective structures to form naturally. And gratitude for the human minds and hands that could conceive, build, and guide the emissaries that revealed this wonder to us. It is a gratitude that transcends the everyday, a deep and abiding appreciation for the intricate and beautiful universe we have the privilege to inhabit and the capacity we have to understand it. This exploration has transformed our map of the solar system. For centuries, the map ended with the orbit of the farthest known planet. Now, we have added new, grander features: the termination shock, the vast heliosheath, the final heliopause, and the glowing hydrogen wall. These are the true outer continents and oceans of our world. They are as real and as important as any planet or moon. To have charted these new territories is one of the great achievements of our age of exploration. We have completed the first draft of the full map of our home, a map that extends billions of miles beyond the rocky worlds, to the true, fiery edge of the sun's kingdom. To know of the Wall of Fire is to hold a secret of the universe. It is a piece of knowledge that enriches the quiet moments of life. When you look up at the sun, you can know that its power extends far beyond what you can see, creating a magnificent structure on a scale you can barely imagine. When you look at the stars, you can know that your view is protected by an invisible, superheated shield. This knowledge does not change the world, but it changes your experience of the world. It adds a layer of cosmic depth and wonder to the everyday, a silent internal symphony of awe. So we return to this image, a bubble of life and light, our solar system, sailing through the immense and ancient galaxy. Its boundary is not a simple, cold void, but a complex, multi-layered membrane, glowing with the heat of a 30,000-degree fire. This wall is not a prison, but a womb. It is the shield that has protected our world for eons, allowing the slow, improbable miracle of evolution to unfold in relative peace. It is a structure of sublime elegance, born from the simple breath of our star and the gentle pressure of the interstellar sea, a constant and silent testament to the intricate physics that govern our cosmos. The story of the Wall of Fire is a story of connection. It connects the furious heart of our sun to the tenuous gas between the stars. It connects the theories of plasma physicists to the work of spacecraft engineers. It connects the patient observations of one generation to the brilliant insights of the next. And most profoundly, it connects us, the inhabitants of this small blue world, to the grand and majestic workings of the Milky Way. It reveals that we are not, and have never been, truly separate from the universe. We are an integral part of its fabric, and its currents and tides shape the very shores of our existence. As our robotic emissaries drift ever farther into the interstellar dark, their mission of discovery continues. They are humanity's farthest thoughts, our most distant senses. The light from our sun will continue to fade, becoming just one of countless stars in their sky. But they will carry with them the memory of their origin, the golden records, a silent testament to the world that sent them. They are the seeds of our curiosity, planted in the fertile ground of the galaxy, a legacy that will endure long after we are gone, a permanent monument to the moment our species first reached out and touched the stars. This knowledge leaves us in a state of deep and resonant calm. The universe is vast, and we are small, but we are not insignificant. We are the part of the universe that has evolved to look back upon itself and wonder. Our quest for understanding is as natural and as fundamental a process as the solar wind that builds the Wall of Fire. To learn about the cosmos is to fulfill our deepest purpose. It is to close a loop, to allow the universe to witness its own grandeur through our eyes. This realization brings not anxiety but a serene sense of belonging. The Wall of Fire is ultimately a symbol of home in its grandest sense. It is the final, encompassing layer of the environment that has nurtured us. It is the shell of our cosmic egg. To understand it is to understand the full extent of the intricate systems that make our lives possible. This understanding fosters a profound sense of responsibility, a desire to protect the unique and precious world that lies at the heart of this magnificent, fiery bubble. The journey to the edge of our solar system leads us, inevitably, back to a deeper appreciation for the world we stand on right now. Let us hold this image in our minds: the serene Earth, floating in the silent dark, wrapped in its thin atmosphere, protected by its magnetic field, and cocooned within a vast, invisible sphere of solar influence, a sphere whose boundary glows with a paradoxical, intangible fire. This is the complete picture. This is our place. It is a place of nested protections, of intricate balances, and of breathtaking beauty, from the microscopic scale of life to the macroscopic scale of the heliosphere. It is a vision of the cosmos that is both scientifically accurate and poetically profound. The journey of discovery is eternal. The Voyager probes have passed the torch, and a new generation of missions and minds will carry it forward. There will always be new frontiers to cross, new mysteries to unravel, and new boundaries to push. The Wall of Fire is not the final chapter, but merely the end of the introduction. The great book of the cosmos lies open before us, its pages filled with wonders we cannot yet even imagine. Our task is simply and profoundly to keep reading. The universe does not give up its secrets easily. It demands patience, dedication, and a relentless commitment to the truth. But for those who make the effort, the rewards are immeasurable. The reward is a sense of perspective, a feeling of connection, and a deep and abiding awe at the sheer elegance and ingenuity of creation. The Wall of Fire is one such reward, a gift of understanding that enriches our inner lives and permanently expands our sense of the possible. It is a treasure brought back from the farthest shore we have yet reached. So when you next gaze upon the night sky, remember what lies out there in the deep darkness. beyond the farthest planet. Remember the silent, invisible structures that define our home. Remember the constant, silent struggle between our sun and the galaxy. And remember the tenuous, hot, and protective wall that stands as the final sentinel. Let this knowledge infuse your view, transforming the familiar stars into the markers of a vast, dynamic, and interconnected reality in which you play a vital and conscious part. In the grand, silent theater of the cosmos, our understanding is the light by which we see the play. Each new discovery, like that of our solar system's fiery edge, brightens the stage, revealing another layer of the magnificent spectacle. We are left not with simple answers, but with a deeper and more profound appreciation for the mystery. It is a state of enlightened wonder, a contemplative calm that accepts the infinite complexity of the universe and finds peace in our small yet persistent ability to comprehend its glory